Good morning, everybody. Welcome at our BrIAS seminar forum day today. And the topic of today is human-robot collaboration and the sustainability challenges we are facing. And welcome here also in this very lovely new building. BrIAS is hosting us here in their new premises here at the Général Jacques here in Brussel. So very nice to be able to have this forum today in this room. We have a quite busy program, I think. That's already the afternoon. You didn't put the morning, but it's no problem. I think everybody has their program in front of them. So this morning we will focus on the subdomain of human-robot collaboration in healthcare, and more specifically also focusing more on the surgical challenges. And for that, I also want to invite for this morning's session my colleague Bernardo, who is actually also co-organizing this morning's session. We need to excuse my colleague Tamas Haidegger today. He was also co-organizing this session. So Bernardo, if you want to say something shortly, maybe to introduce the session of today.
Okay, asking something to say short is difficult.
I take that chance.
Okay, now. Yeah, okay. So, ladies and gentlemen, good morning. It's a pleasure for me to have you here. It's a pleasure to be in this new room to talk about interaction, collaboration. I think that we can do good collaboration with robots if we have good collaboration among people. And this is a very nice starting point. We have different people that we talk today on different fields. And I think it's a good experience and everybody can learn from this. And as you tell me to be short, I want to stop now. And I think, oh no, this is, yes. No problem.
Oh, wait. The Slido? I will put the book. Yeah. Okay. Yes. And then we press on this arrow and to go to show the results. Okay. And before we start some sharing of information with some presentations, I want to invite you first to have a reflection on these sustainability goals in relation to the question we are digging into this morning. So if you could scan or use the code to answer the question on Google Lab. Is it working? Yeah, great. I asked somebody else to help me because I'm always having problems with Google Lab whenever I try to use it.
Kan je op die pijl drukken met de...
Welke pijl?
Die daar.
Sorry.
Now you can vote, and then I will display the results in a bit. Oops. I see more votes coming in. I see still votes coming in, so I'm waiting a bit until most people have voted. I'll show the results. Do you want to discuss them or do I discuss them? So what we see here is we see the most of the votes for good health and well-being. Maybe also our target audience in the morning is a bit biased towards healthcare because they're all working in healthcare. But this gives a pretty good idea of what is important for us. So we'll ask this question again in the afternoon. So maybe I will give the word now to Carl, who will introduce the first speaker. I'll grab the slides for him. Playing from start.
All right. Hello, everybody. Thank you for being present this morning. So to kickstart this first part of the morning about human-robot collaboration in surgery and healthcare, it's my pleasure to now have Kristóf. He comes from Óbuda University, and he's working a lot with Tamas Haidegger, and he will talk about the importance of sustainability goals in the surgical domain. So, Kristóf, the floor is yours.
Thank you very much, Carl. It's a pleasure to be here, especially that I am here on behalf of Professor Haidegger, my PhD supervisor and boss at Óbuda University. So where I am coming from is the robotics laboratory of our university. This is a research center, so we are not deeply involved in teaching. Mostly this laboratory is about robotics-related research. You can see that we don't only have the Da Vinci robot and surgical robotics applications, but we also work with industrial robot arms and from social robotics to any kind of mobile robotics as well. But of course, today I will focus more on healthcare robotics and surgical robotics. So what is our approach in this domain? We usually take off-the-shelf robots and develop some kind of mechatronical application for them. So either hardware or software development. On this picture, for example, you can see that Takács, my fellow PhD student, is showing off his PhD topic solution and haptic feedback and ultrasound feedback guided robotic needle insertion. And for example, this is a good example of our regular approach because Bence just came to our laboratory, wanted to deal with robotics and ultrasound somehow together. And the first picture is more than 5 years old. And just last year, we finished a successful collaboration with, together with Colonel Medical, a private company, who wanted to make a surgical spine surgery with robots, also an ultrasound-guided and haptic feedback-guided manner. This is, you can see the same robot arms, but the newer version. These are now medical-grade robot arms, but the knowledge in our laboratory started with Bence and his passion about ultrasound and robots. And of course, we are working a lot with the Da Vinci robot. This is my PhD topic as well. Fortunately, since 2 years ago, our Da Vinci robot is not the only one in Hungary, because 2 years ago, the first real Da Vinci robots in real hospital use appeared in Hungary as well. So naturally, many of the hospitals looked for us to have projects together. So fortunately, we are on a good way with this research as well. But you could probably notice that I haven't talked any about sustainability yet, and that's because sustainability wasn't in our perspective until 2-3 years ago when Tamas fortunately found this group about sustainability. And we retrospectively overlooked our projects and realized that, yes, of course, in healthcare, the only important thing, or the most important thing, naturally, is the well-being of the patient, healing the patient. So sustainability or cost or the type of hardware we use is just secondary issues. But this example, the MAS-20 project that was started at the beginning of the COVID at our university, I think a great example for sustainability healthcare development. And the main reason that I say that it's a good example is that because it wasn't started like, okay, sit down and let's see how we can make something more sustainable, but it started with an absolutely different idea. It started with an idea that at the beginning of COVID in Hungary, there were just not enough ventilation machines, these artificial ventilation machines in the hospitals, and well, people were regularly dying because of a lack of hardware. And based on the idea of one of our professors, Professor Kozlovsky, we started to develop this mass ventilation system, which is instead of having this huge machine for each patient with an own computer, own ventilation system, own mechanical systems, noisy, smelly, loud, and really expensive and taking a lot of place, we wanted to put all the machinery in this container outside of the hospital and just have 2 tubes between the hospital and this container, one for inhale and one for exhale. And for each patient, we just needed those little white control boxes with just one little valve inside and, of course, a microcontroller. And in this manner, the risk of infection is much smaller because the filter there doesn't go out into the hospital room, but regularly outside. It takes less place, it's cheaper. So generally, we just realized that in basically every aspect, it would be a more sustainable solution than the traditional solution. Of course, we all know, I guess, that in healthcare, it's not working like this. So it's many, many years from now till the first of such systems can appear in real hospital environments. But fortunately, last year, one of the biggest medical companies in Hungary bought up this project, and they continue to increase the TRL level, and hopefully we will see it some days in a hospital. So what we learned from looking at our previous projects retrospectively through the glasses of sustainability is that robots do have the potential to help sustainability in healthcare. They are more precise, they are more efficient, they are stronger than humans, so they can help in these manners, and they can enhance safety, either in the manner of risk infection or of safety of the doctors and safety of the medical staff, or they just can work in difficult scenarios and help the human workers. On the other hand, of course, you always have to tell that the manufacturing of extra machinery, their energy consumption is always a big negative in this manner. And the recycling of robots is basically not a solved issue yet. So I know that there are some research directions going towards how to recycle parts of the robots, but it's yet an unsolved issue, unfortunately. And we have 2 more aspects that are usually considered to be negative sides of robotics, but I think there are good examples that how you can make them work towards sustainability. First is social inequalities, because everyone says that robots can only be afforded by rich people and rich companies and bigger companies and first world countries. Well, that's true on one side, but on the other side, we can think about disabled people who can work again with the help of robotics. We can think about making people taller, stronger, and making them available for different kinds of jobs. So you can just enable the work of different types of people in a wider range. And job displacement, of course, yes, robots take away the jobs of people, but I have a good example for this as well, because 2 years ago, RoboChair project, so-called RoboChair project just finished. We took part on it. It was a EU-funded research project, and the name comes from robot and butcher. So yes, we were building an AI-based robotized slaughterhouse application, which was cutting pigs. And at the beginning of this project, we visited some really big slaughterhouses. And by big slaughterhouse, I mean that in such a big slaughterhouse, they slaughter more than 100 or sometimes more than 200 pigs per hour. And people are working there and just standing there, and each day, each minute, they are cutting the pigs. And I can say that this this is a job that should be taken away by robots. I don't think anyone likes to do that job. So we can take the sometimes negative effects and try to convert them into positive things as well. So as we now know that how robotics can help in sustainability, what's the next steps? Well, of course, we are researchers, we are academia people. So Professor Haidegger and some of the colleagues, some of you are sitting here, obviously published a paper about it. It came out last year. And yes, I'm in a strange position now that I am not a co-author of this paper, but some of the authors are sitting here, so please just raise a hand or just tell me if I say anything stupid about that. And for normal people, they came out with this really nice graphic. It's the regular UN SDG graphics, but enhanced with robotics. And I think this is a good graphics to get people closer to robotics and SDGs as well. I encourage everyone to use this in related topics. So they've summarized their findings in in these diagrams. On the left, you can see the positive effects, and on the right, you can see the negative effects. Of course, it was found that robotics has a higher potential in enabling most of the SDGs, but it's worth mentioning that that there are some dangerous SDGs that are in danger because of robotics. So either we are, sorry, my mouse is, yeah. Yes, of course, but I can also send you the original image in better quality as well if you want. You're welcome. So the two options here, naturally, is that either we are working with these and trying to get just robotics help in reaching the SDGs, or we can, we can work on the other side and try to think about how SDGs won't ruin our endeavors towards the other SDGs that are probably in danger because of the spread of robotics. But from my perspective, the most important SDG is good health. It's the SDG about having a more healthy society by 2030. And Tamas and the colleagues realized that in basically every targets within this SDG, robotics can have a positive effect, and only in 6 and 7 may it have a small negative effect. So the darkest green resembles the highest potential of robotics to have a good effect. For example, 3 is the end of epidemics, 8 tuberculosis, malaria. It's in connection with workplace safety in hospitals, for example. Or 7, universal access for sexual and reproductive healthcare services. But how can, what's the potential here? Well, the biggest potential probably has robot-assisted surgery, the spreading of Da Vinci robots, and the spreading of competitors, especially in Europe in these years. And we also have to talk about robotic guidance systems because they are spreading in hospitals as well, either ultrasound-guided robotic systems or any kind of preoperative scanning-guided robotic systems. Robotics have also great potential in preventing injuries and helping recovery. We can also talk about robots used in physiotherapy or prosthetic limbs, as I said previously, and assisting workers here as well. Or the increasing access to healthcare, which is telemedicine from one point, and the drone delivery system, which is a great endeavor in many European countries nowadays. I know that in Finland and Norway, there are these test cities where they are testing that how faster can you bring medicine, bring blood, bring equipment to the places of accidents. So it has the potential, the great potential to in this societal manner. But as I said, this is a very new thing to connect SDGs and connect sustainability to healthcare, and many don't even know how to start it. So I brought some open questions, and most important problems, at least in my opinion. The first and I think objectively the biggest problem in healthcare is the problem of sterilization and the need of sterilizing everything, basically, mostly in surgery, but also in the smallest room of any doctors working with patients. You either need to sterilize all the tools and everything that the patient connects with, or you need to use disposable tools. Of course, none of those are a good solution. So here you can just probably have bad or worse solutions, but still it's worth thinking about it. On this image, for example, you can see, this was the Tetris challenge some years ago, you can see Hungarian hospital workers lying with all the tools for a simple surgery, needs to be sterilized, or some of them are disposable tools. And this is just a simple 1 hour long surgery. So it's, and not even a robotic surgery. So of course with the Da Vinci tools, which you can only sterilize 15 or maximum 20 times, it's even a bigger problem. The question of laparoscopy versus robot-assisted surgery, it's not only a question from sustainability side, but it's a question from any possible side, and there are advantages and disadvantages of both. But from this aspect of sustainability, of course, robotic surgery has a much larger footprint. Here we can talk again about manufacturing the whole robot, manufacturing these tools, and then getting rid of the tools, the energy consumption of the robot, and the complexity of tools, because the Da Vinci tools and these robot-assisted tools are much more complex, needs much more machinery and intelligence and microcontrollers and so on than laparoscopic tools. But from the aspect of the surgeons, robot-assisted surgery, so to become a surgeon capable of using the Da Vinci robot requires much more training, so you can become a robotic trainer in much later in your life, which is also, well, of course, surgeons are usually, or hopefully, they want to use these new techniques, robotics, and so on, but it might be a problem for them if you can become a surgeon like 3 years later. But of course, it has positive sides as well, better outcomes. This is the most important, as I said. So the number one thing we think in surgery is if it has statistically better outcome than some traditional methods. If yes, then we should use it. If no, then we shouldn't use it. It's just that simple. Shorter hospital time because of the better outcomes, or which is, of course, again, sustainability issue. And from the aspect of the surgeon, again, improved surgeon ergonomics. You can see that during laparoscopic surgery, they are spending their time, hours of their time in this position. But in the case of the Da Vinci robot and the competitors and other robots, they can sit in a comfortable position. And I think the most important, it's not a problem, it's a question. And for me, it's a question that why don't we see more of this? Either a research or for companies or anywhere, is the question of prevention. Because in Hungary we say that the easiest problem to solve is the problem that doesn't occur, and we can say the same with patients, that the easiest patient to cure is the patient who is never ill. So I think that especially from the point of sustainability, we should spend more time and more efforts in prevention, because if we can prevent diseases, if we can prevent surgeries, we don't even need the next Da Vinci robot, we don't even need the next tools, we don't even need to sterilize everything. So it's just, for me, it's just basically the best idea to work with. And thank you for your attention. And please, I like to show always the words of Johann Seitz. We should try to think in this manner as well. Please visit our websites, and I am open for any questions. Thank you.
Thank you, Kristóf. You can stay next to me. Are there any questions? I will take the mic. You can stay here. All right. Yes.
I will start. First of all, thank you a lot for keep the time, so I can abuse of my time later. And second, for your very nice presentation. I want to tease you a little bit. When you put your question just before this slide, I a little bit disagree on the first question, because you say that sterilization, it's an open question, but I mean, we are alive, we need to sterilize. So what do you think it's the improvement? Is to make the sterilization faster, to use material that can make the sterilization cheaper, is to spend less energy in sterilized, because you can see this point as a multifactorial. What is your input on this?
There are several possibilities, of course. Just last week we had a meeting with one of the hospitals of Hungary about sterilization, and they asked us that how to improve their sterilization process. And one of their biggest issues was that it involves people. So here comes the error factor. And they, well, it sounds bad, but they wanted to get rid of the people working like this and more or less sterilizing the tools. Hospital infection in Hungary is a huge problem, so that was the reason for them. And on the other hand, so that's why they started to think about robots to well, take away the jobs of people. But it's again not a job that anyone, I think, happily does, washing the tools and sterilizing them. And yes, they wanted to. They asked us if they can make all the, if they had to make all the steps, or if we can come up with an idea to have to just pour every, for example, after a surgery, put every tools in one place and have all the sterilization steps in one machine, for example. Yeah.
And last, related to this, and I apologize for the time also during question, I saw also that in some of the hospitals, the big issue is also the logistic related to this, because they send to left and right, they have only one central unit, sometimes outside. I think that also this is something that can be improved, looking also to what we are talking today. If you can comment a little bit also on this, and thank you a lot for your time.
Thank you for your question. Yes, they also mentioned this problem, those hospital people who we were talking with. And they said that, that this is something that we should think about, but of course it's a question different for every and each hospitals. They usually have a different room at the same floor, but not always. Sometimes it's 2 floors down. So probably the topic of the Tamas Haidegger, my supervising professor, is working with the IEEE and standardization organizations. So, for example, standardization could be a good solution in this problem. But of course, it's you cannot tell already built hospitals how to build themselves again.
Thank you. You have one question online. How sustainable are the robots themselves? What is the balance between developing, deploying, and maintaining robots versus the proposed impact? So if you want, I can also bring back the question here.
I think I understand.
It's a 2-part question. All right. Thank you.
I think I have heard a presentation at this year's European Robotics Conference from some Belgian university, right? It was probably another department of this university, where they started to think about first how to start building robots in a sustainable way. So how not to get everything from China, and how not to use too much disposable parts. And how to manufacture the parts in a more sustainable way. So that was a good thought-provoking presentation, at least for me, because as I mentioned, we only take off-the-shelf robots, and sustainability of those robots wasn't an aspect for us as well until this point. But yes, thinking about how to, so for example, the electronics, it's really hard to recycle. but starting to think about that which parts of a robot can take up 10 years and which parts can take up 30 years. Or in robotics, we usually talk in cycles, so which parts of the robots could or need to be replaced after, I don't know, 1 million cycles, and which could take 10 million cycles. And then we start to build robots based on how can we replace some parts after 1 million cycles, and how can we keep using the rest of the robots, not just, okay, 1 million cycle, we throw away the whole robot and buy a new one. That could be more sustainable and more effective and efficient. Sorry?
I mean, what you call about surgery robots, it resembles aviation service, like preliminary, and there are different times for different parts of airplane, right? So
yes,
they should
exactly
register in journal and see how long they use this or that part.
Yes, yes. And in surgical robotics, in the case of Da Vinci robot, for example, there is an additional problem that Intuitive, the manufacturer, takes its most money from the not disposable, but not so many times sterilizable tools. So, but I think that the beginning of competition in European market, at least, will have a good effect on this, because I hope that they won't be able to maintain this. You can only sterilize it 10 times, and we don't do anything about that.
Thank you very much.
Thank you.
A round of applause for Kristóf. Thank you. Now, your turn, Bernardo. So it's my great pleasure of welcoming Bernardo Innocenti. He's a professor at ULB and also affiliated to KU Leuven. He will talk about robotics knee surgery. So some of you might have had the chance to listen to him a few weeks back.
Yep.
So Bernardo, the floor is yours, and I'll leave you 1 second. So this.
Yeah. I'm not recycling too much, let's say. And I'm always stalling because they always tell me that the first things that we should do as university professor is to stall the work of others. So, okay, pas de signal, voilà. As Murphy, this morning was working.
Yeah, it was working immediately.
Let me see again. Try to do your best.
Is there something we can do? For plugging in, because this morning it worked.
Yeah. Okay.
In the meantime, I can do some shameless advertisement for next week's BrIAS event. So you can register online. It will be about robots in times of war and peace. So please register online if you have not done it and if you're in Brussels.
Yeah, wait. I don't do nothing. What do I need to do?
Your settings.
Settings, okay. Yeah.
There we go.
Tell me.
Screen. Screen.
Display.
Display, yes. Only it should.
Multiple display.
It's not recognizing. No. Detect. Click on detect.
Mm-hmm.
Didn't find.
We talk about collaboration today, and my computer didn't collaborate. And but let's try again. See.
Otherwise, we use another computer.
Yeah, okay. I have a USB.
Okay. No, it's not happening.
Okay, no problem.
Everyone has a computer.
Yeah. Do you have a USB pen to change the?
Yes, here.
Okay.
Are you sure the screen is not turned off?
Okay.
But for me, it's also not working for some reason. Patience. Okay. So should we have waited longer? Let's try one more. No?
No, it's fine. It's
Yeah,
fine.
okay,
If it works, keep it working. I have this USB
Yes.
pair, sorry.
And you have this controller for your. You can add it here. The other one.
Okay, let's try to do here. If you go to my
Can you press on your button? Okay, maybe we take it out first.
Okay, no collaboration today.
No,
But this work.
I'm looking for my mouse. It's there. Go to the side. Okay, first your USB stick. Where is your presentation?
File presentation. Yeah.
Okay, I will put it
Okay.
here.
Should be this.
It's copying.
Yeah. You have it.
Yes. Enter this. Slide play from start. Okay. Now I just wait again.
Oh, yeah.
Okay, so here the arrows you can.
No,
That
I have
it
put my
works?
button.
Okay,
Yeah,
good.
the reason why I have it. So, ladies and gentlemen, finally, good morning. I am Professor Bernardo Innocenti, and I will talk about a little bit of robotic knee surgery. In reality, I will talk about robotic orthopedic surgery. And I want, first of all, to thank you, the previous speaker. I know that most of you already know what is a Da Vinci robot that is not used in orthopedics. And this is why we have this small interview and small overview of what I'm going to tell. I need to disclose myself. I interact with several partners in the field from orthopedic point of view and from other medical company. I'm also editor of some journal, and I will report some of the studies that we did and so on. I want to start briefly about myself. As I mentioned, I'm Bernardo Innocenti, I'm professor of biomechanics at the École Polytechnique de Bruxelles, one of the two universities of the Free University of Brussels, the French-speaking one. I'm also guest professor at Leuven. My main research field is orthopedic biomechanics, and I work in the orthopedic field with several companies. I also work quite a lot on the interaction and development of tools for medicine. And in fact, I was the founder of the CAOS Belgium, the Computer Assisted Orthopedic Society of Belgium. It's an international society. We made the Belgian chapter. I am also a member of some society, but let's go straight to what I will talk today. So I don't want to talk about robotic surgery. We already know a lot. I want to highlight a little bit what is robotics in orthopedics. And what is really important, as you already see, we want to be sustainable. That means we want to improve what we did yesterday to try to do better tomorrow. But to do this, it's quite important to understand that we need to know what is the target, what is the aim of what we want to do. Because only if we have a clear overview of what you're aiming for, we can improve what we have. And we need also to understand that there is a lot of option in the field, and we need to understand what are the main approaches, similarity and difference in terms of robot. But I think it was very important, one of the last sentences that was highlighted by the previous speaker. We use a robot, and we will use a robot if we have a better outcome with robot. And so, as we have this new tool and we want to introduce in the field, it's quite important to highlight what are the evidence and what is the trust of this new device in this medical field, like copy what you say. It's not that we introduce something that is in the field. And as always, a very small take-home message. And again, also looking of the main difference between the robotics in orthopedics versus industrial robot. Professor of biomechanics, so I need to put Leonardo da Vinci, that is the father of biomechanics. I need to explain, but you are smart to understand that biomechanics means the application of the mechanics to the life. Already the word itself from bios, life, and mechanica, Greek and mechanics, can explain what it means. And we can do this because our human body is a musculoskeletal system. It's a machine. So it's a machine, we can apply mechanics. We are made by bone, we are made by soft tissue. The soft tissue, the muscle, apply the force, and the force will produce the displacement. And we have a fantastic joint that have huge performance, and everything is fine unless we have a problem. Unless we have a problem sometimes to our joint, the soft tissue doesn't work, we are not able to apply the same force, the bone grows in a very bad way, we have limitation of motion, we scream, we have a lot of pain, we need to solve it. And so we need to introduce in the field some surgeon, orthopedic surgeon, that mainly they try to remove the problem, cutting the bone, cutting some soft tissue, and replacing, as you can see here, we flex, this is our knee, we have some problem, no problem. We cut everything, and we replace what was damaged with an artificial implant. We try to close everything, cross finger, and hope that everything is the best. And we are talking about something that exists for a lot of time. Traumatology, orthopedics have really a long history. And it's always, it is nice to see that there is always an improvement and future. And it's very a clear explanation of this. You can see from one of the first paper published, I want to highlight the date, October 1948. That was the head of the hospitals, the orthopedic president of America. He was the editor of the Journal of Bone and Joint Surgery. That 1948, he say, a report written, The Future of Orthopedic. And you need to understand that this was a special period, and because he highlight, and I want also to highlight this sentence, that a few years ago, there was the invention by Röntgen of the X-ray. So, in the past, you operate without knowing what you have inside. After there was the X-ray, people can see inside before opening the patient. That it seems a fantastic innovation. Pay attention, he already mentioned the use of this diagnostic agent grew slowly. So even if something that today is obvious, fantastic, they say, yeah, take calm, I don't want to use it, we wish to see and so on. So it's not always that something that is booming is efficient, because again, we need to trust, we need to prove that it's working. And it was 1948, and he finalized say, yes, there is a lot of things to do that we can do in orthopedics. But it was 1948, and the common question is now what we can do. Because if we look at what we have on the market in terms of implant, this is knee prosthesis, we found more or less everything. And it's also true that it's the same for the hip. And I report hip and knee prosthesis because they are the main two. They cover more or less 90% of all the product in the market in terms of orthopedics. But what is very important in this field is to understand that even if we have different philosophy, different approach to design a certain device, design is only one aspect. You can have the fantastic prosthesis you put in a patient, the patient start to complain because the real performance of this kind of device are not only design dependent. They're dependent on how the surgeon is able to place, what is the orientation, which technique I used, which tools I used, how I manage the soft tissue, the muscle, the skin, and so on. And in fact, we need to understand that we can make a sort of pyramid of success, that the first things that we need to look, obviously, is the patient. Everything is centered on the patient. But the patient is treated by the surgeon. The surgeon treats the patient selecting a certain implant. A certain implant that is implanted following a certain surgical technique, and the surgical technique is performed using some tools. And obviously, it's normal that the patient influences the surgeon in the selection of the implant, the surgical technique, of the tools. But it's also important the opposite way, that only if I have a certain tools, I can do a certain surgical technique, and so on and so on. And as you will see, I call this as pyramid, even if the triangle and the box are separated. Because to have a real pyramid, we need to put, go now to the civil engineering, some cement between the two that really fix the part. And this cement is the trust. We can only use a device. We can only link the two only if the patient trusts the surgeon and vice versa, but also the opposite. Because if the surgeon don't trust the implant, it's quite common to have not a good approach. And as I told you today, where is the innovation? And why we are here about robotics? Because, as I told you, I mean, we can innovate the patient, we can train the patient, we can explain the patient, we can explain the prevention to the patient to not go to the surgeon. We can train the surgeon, but today, the real innovation is here. And here we are here, because we are talking about robots that are tools that after can bring innovation later to this. Always look into the trust. But how we can improve and why we introduce this? Because we need to ask two things. First of all, we need to check what is the target. And second, that maybe seems stupid, we need to also have an agreement of the target, because everybody can say, yes, you're right, this is a target. If we miss two different targets, we have a problem. And I want to give you a very simple highlight of this, is that this is something that I found a very old American example on cars. Everybody knows the cars. So I can have a guy that need, like Alejandro, go fast and have fun. You have this kind of design. But you can have another one, like Marge, that want to be safe and comfortable. He's aiming to another target. And as American, we need also to have Dale that have a big load and be reliable. We have another design. And now we have a problem, because if I want to make a design that make everybody happy, we will make something that will make nobody happy. We need to tune for this. But I told you I need to tell two things. Yes, indeed, we need to aim to the target, but we need to consider that we are talking of what is under the big umbrella of the biomedical field, where we have mainly two actors, the clinician and the engineer. And since the beginning, they told it works if we start to combine them, they talk the same language, and so on and so on. But it's not true. There are three. We have also the patient. And we need to understand that we need to aim both the clinician and the patient. And we are the engineer to make that happy. Pay attention that also we have, if you look yourself on the right or on the left, we are different. In the past, we say different anatomy. Now we learn that we need to use morphotype. We have difference in age. We have different lifestyle. Because at the end, there are people that want to run, people that want to walk, people that want to gardening. And you can't make the same things to make everybody happy. Because if you have a different target, sorry, we have a problem. So we need different needs, a different strategy. And don't forget that if you look on the patient, we saw that also the profile is changing compared to 20 years. Now he's younger. Now he's more active. But what is even true, he have really higher expectation. He wants to gain life. He wants to gain the year that he loses screaming when he was bending or he was walking. And what you need also to understand that the entire story of sustainability, so to improve the patient, it's really a big journey. Because the patient journey, it starts not during intervention, not during the robot is cutting, but it starts visiting the doctor, and the doctor needs to have some tool to make the diagnosis. And after, sometimes they say, hey guys, sorry, you need to be operated, or you need to receive a certain treatment. But pay attention, it's not finished yet. And this is something that sometimes people forget, is that after the treatment, the patient wants to do what he did before. And we need to follow him, both with rehabilitation, but also for the evaluation of what are called follow-up. And only this is one journey with the idea, happy patient and follow-up. And these are all the tools that we can provide to make the patient happy, pre-op, intraoperative, or post-operatively. Some of them also move left to right, but we are here talking about robotics. Robotics in surgery. Thank you again. I don't mention quite a lot. There was introduced several years ago in the general field. But in orthopedics, they was inserted only later. It's only a few years that enter in orthopedics. And if you look at the claim, because indeed the people that sell, make marketing and advertise, why they introduce this robot. These are some of the examples of the robots that are introduced in orthopedics that you see are different from the top one. The main aim was to improve the prosthesis. They want to be precise and accurate in the preparation of the bone. You want to restore the physiological joint to allow a motion that is similar to the previous. The same word that my friend told to me before. And that have a very huge application. And you see why, because all the companies start to buy or make research and develop their own orthopedic robot. And you see everybody start to talk about huge increase, number of robots, number of surgery, and so on. And us as researchers, we do the same, because you see that we start to publish in robot. That was what we found when I published the previous paper in 2020. Now the number are even higher. We are in April, so the 2014 is still low, but I think it will always grow. But what is true with respect to the other field of orthopedics, the robots, used in orthopedics are all different. And what is really important to know, and we also mentioned this, that we need to know what they are able to do. We need to know what the surgeon wants to be able to use efficiently. Because, first of all, robotic in surgery, there are two different fields. One is the industrial field, one is the clinical field. A robot, the same device. But it's different, the idea behind. Industrial field, that is the company beginning of the last century. This is a company today. We want, in a certain way, to help and eventually replace a human being in doing some automation. My field explained before, there was a lot of people that are cutting pig every day, every hour. We use robots to do this. But in the clinical field, it's different. We want to replace a surgeon. Maybe people believe we will not achieve this. Our idea was to help a surgeon to do what he was able to do before better. We want to improve this, but not to substitute them. So instead of using the hand directly on the patient, we will put in between the hand of the patient this advanced tool that is a robot that is able to improve the performance of the hand of the surgeon. However, when we talk about orthopedic field, we have different approach. First of all, some of them are open and some of them are closed. It does not mean that they have a window that you can open. It means that what you can do with it, which implant you can use. Some of them are open. That means you can use for everything. Others are sold by companies that sell prosthesis. You can only use the prosthesis of their product. I put now some names to give you some example, but I don't find any funding from them. So there are two companies, the Robin from OrthoKey in Florence and the Think Surgical. With these two robots, they're open. You can use all the prosthesis. Other, like I put the first in line, Rosa, Marco, Corey. Close to them, there is a company. So if you have the Rosa, that is bought and developed by Zimmer Biomet, you can only put the prosthesis of their company. If you have a hospital that have two prostheses, should buy two robots, so it will use in one case the robot, in their case the hand. But apart of this, you need to understand also that, as I told you, you use X-ray to see the patient. You can use the same, even better today with 3D imaging like X-ray and CT to see the 3D of the bone. The robot can use this technology, and so we have the image-based, or the robot cannot use. Because don't forget that the entire process of surgery have a cost. And make a CT or make an MRI have a cost. I can decide to do it or not. So I can have patient information provided to the robot or not. And so we have the image-based. You need to have 3D image to provide. And that improves a lot because you can use already the robot not intraoperatively, but preoperatively. If you have the geometry of the patient, you can already decide what is called pre-planning, where to cut, how to cut, the dimension of the size of the prosthesis, the cut that you want to do, the guide that you need to use. And you need to understand that all of this information will remove the number of tools that you need to bring with you in surgery. You remember the guy sitting, laying on the table. Also, this can improve the sustainability. However, you can also have imageless, so no data, and you need to have this information interoperatively. So usually they have a sort of pen. They move the pen on a certain surface, and they develop the 3D surfacing, making what is called morphing. So they have a standard bone, and they will adapt according to the information that the surgeon do interoperatively. It's quite easy. If you have a GH, I have the image before. I can do a lot of analysis before. I can also make a lot of evaluation, but it's true. I have some cost of the procedure. I need to, like the surgeon, work also before surgery to make this analysis, and also I need to pay for the image that you have less cost and less radiation. Yes, don't forget the CT also provide radiation, and it's not always nice to give radiation to the patient. However, you don't have any pre-planning, and consider that this morphing sometimes is an approximation. But what is really important, and what maybe you are trained, is also what the robot is doing. So the surgical approach, because the interaction required from the surgeon to the robot that do resection can be different. And so we can have what is called active. That means the robot do everything. The surgeon decide, push a button, and say it like that. You can see only in movies. In reality, first of all, the surgeon don't want to do it, also for a sort of, let's say, who is responsible and so on. What is true are the passive, that mainly the bone is made by the surgeon. The robot decide the position and orientation, so it's moving this guide where the surgeon put the saw, but is a surgeon that really cutting. It's also true that there are the so-called semi-active, so going to the active direction but still in the hand with the surgeon, where the robot can really control the saw and decide to cut or not. So it's like you ask to follow a line, you have a region in this line where the surgeon can cut, you have your saw doesn't work. When it touches the point that he can start, you have the cutting. When it's finished, you stop. This indeed improves a lot the safety, because the robot have very more accurate, because the accuracy of our eyes cannot be micrometric, to be able to decide the regions that are safer. However, I talk about a lot of this, I talk about nice things, but again, we need to have the trust. And I want to give a very simple example to all of you. We have electricity here. And you don't realize it. You realize that you have electricity when the electricity goes away. You realize that you have something when you have a problem with this. If you don't have a problem with that, you trust it, you use it. And this is the same story in a medical device. Is it more because it's a surgeon that needs to do it for a patient? So what we start to do as a stupid engineer working with surgeon, we start to prove the claim. Are really the clinical measurement, the measurement that the surgeon, the robot is doing intraoperatively, are really true or not? Because we need to understand that, especially because they're quite new, most of the tests that were done by, first of all, people that sell the robot, so a little bit biased. Second, in the lab. That, I mean, it's nice to do tests in the lab, but when we operate, it's a different field. We have surgeons that are screaming to the nurse that running left to right. We have the patient there, really. We need to do in real time. And we cannot say, oh, yes, we have a problem. Let's stop 30 minutes. We cannot do. So we go with the real robot in surgery, and we start to do all the measurement by hand with the robot. We try to prove, and we show really the trust. We show that we have huge, high intraoperative reliability and repeatability. The measurements are true, also in the surgical room. It's independent by the operator. This is nice, because sometimes you cannot really say, I'm not doing the right things. Maybe it's a surgeon, but if you're trained, you can do the right things. It's not the robot that make mistakes, okay? I go try too fast. And what we say, other people doing this. And so what is true, high level of component alignment, precision, fantastic. But the robot do his stuff, but have a clinical meaning, so that is really important. And we are now talking something quite complicated. I only report meta-analysis, So we say that if you do by hand, it seems even better. This is some study. Why? Because if you use a robot, you need more time. And so as a result is the same, this is a result of this study, we don't see a lot of improvement. I'm talking about orthopedic use of robot. Da Vinci clearly demonstrate his success. Some advantage in pain outcome. Other studies that follow, and this is also what my previous colleague explained, people find a short length of stay. So patients remain less to the hospital. This is another study that also number it. So 14 reduction, great. He also said, yes, it's true, I need more time because I need to calibrate, I need to take point, I need to add the robot, remove the robot, and so on. They also claim at the end, that is questionable, that the use of the robot don't alter the cost. A robot costs €1 million. Our hand is given by nature. What I want to highlight is that one of the authors worked for a company. Second, this hospital used for the cost analysis was in America, and we know that the cost of operation in Europe and US are quite different. This is another study, even recent. I only publish you see the years. It's something new. They say no statistically significant or clinical difference. They say it's true that we have a fast recovering. But it's also true that if we work well, we work well. And so after 1 year, we don't see a lot of difference. And I almost finished, but I want to mention something that is really important when we talk about device in the medical field, and is the conflict of interest. We trust, as readers, what we read. But we need to consider that what we read sometimes have some conflict of interest. And there was this nice study that also quantified the effect of conflict of interest. He made a lot of study, and you see in this table that if you have royalties, stock option, or you're an employee, you are statistically significant, more prone to give favorable results. If you don't have it, you are less prone. If you have stock option, apparently all of the studies say fantastic, only 300, and you see also the difference in numbers. And I'm conclude telling for sure that robotics are entering fast in orthopedic to improve patient treatment. The use of robotic requires several prerequisites. We need to know what the surgeon wants. We need to teach. Teaching, as you mentioned, it's important. We need to consider the learning curve. It's not click and you can start. Tools evolve versus time, and it usually when we do new things, it's better. But as I always say, the Holy Grail doesn't exist. If we have different means, we need to use different tools. I want to thank you, my group, and I will invite you to my conference in September. Thank you all for your attention.
Thank you, Bernardo. So we have time for one question before, yes, one question in the back.
I apologize, I will abuse my time. But I put my name and my website, my email if you have additional question for me. Please.
Thank you so much. This was a very nice presentation.
I'm happy.
And I also like the fact that you read still journals from 1948.
Yep.
Because there are lots of good research still there. And when I do that with students, they're like, nobody reads these things. I think this is very valuable to show that there is merit to earlier research. And you linked it very nicely to the current problems. I have a question about another dimension. I liked your pyramid, like the patient on the top, and then you have the different stakeholders and the issues. Mm-hmm. I was wondering how you measure these somehow abstract notions like trust and the communication between these different stakeholders. Yep. You probably have read about these things, but the second question is, if I may have time, how do you measure the interaction, or how do doctors explain the patient, the robotics? Because these are important issues for the patient side as well.
Are not important, are fundamental. The training of the patient given by the surgeon is the first thing that the surgeon should do to the patient. Because if what is called patient information. If the patient is not informed, Even if he's happy, he will not be happy. And this is extremely true for the knee, less on the hip. Because you remember the story of the example of the electricity. You realize when it disappears. And in fact, the best device that it works is the one that the patient doesn't realize that have it. And in fact, in the hip, there is a forgotten score joint. That means that I don't realize I have it. I walk as I have my previous joint. And for the knee, it's not really true. So the knee always feels something. And this is something you need to tell to the patient immediately. You need to tell, consider that I will remove the pain, I will allow you to move better, but you will feel, also because we put piece of metal and plastic in something that is softer, will be a little bit different. If you train, great. The use of the robot. The use of a robot, you need to convince mainly two people, the head of the hospital to buy, and the patient that you will be used by that. And you can show, and this is why we are doing this kind of information, you can show that you will improve the efficiency, it's faster, you go to work early, but you always need to explain the 360 degree. It's not fair to tell only what is nice, you need also to tell, pay attention that you can still do like this. You need to explain also the last part of the arrow. You need to explain that if you don't do rehabilitation, unfortunately, you will not work, that you need to do some treatment and so on. These are all part, and it's only when you do the entire journey you can aim to the patient follow-ups. Absolutely true. How to measure this trust? There are ways to do it. And the main things are related to what I tell you. You trust if you don't feeling. So you can trust, and how the surgeon can measure. First of all, there is a registry worldwide that you can use to check the performance in a larger scale. You can have all the interaction between hospital, surgeon, industry, and group of population. And these are the way that usually we use to receive feedback, also to improve this. Consider that all the company have people that works on the interaction post-operatively with the implant. A lot of years ago, the aim of the company was to sell implant. When I sell is finished, I'm happy, I have a profit. Now we want to prove also that what I sell have a meaning, it's improved. They also go to the registry to see their performance. They will go to interview patient because they need also to acquire information. Usually I put a slide, but I need to cancel, that we can only improve what we can measure, is a sentence of Lord Kelvin. And the idea is to be able to obtain these numbers. And the only number that we have is, as I say at the beginning of this morning, is between collaboration of people. Talking with people, interacting with them. There are questionnaires. I'm afraid I'm out of time, but thank you a lot.
Thank you. Now, while the PowerPoint is being installed, it's my pleasure to welcome Professor Anja Jacobs. She's a professor at the VUB. She's at imec-SMIT and also one of the BrIAS co-directors. So please, you're most welcome to come on stage.
Oh, I have to move it. Yes, I have it, but let me close all 1,000 windows. Share. You see present from beginning. Okay.
Okay.
Oh, but then you don't see it here. I will download it then.
Otherwise, I will look there. It's okay.
You sure?
Yeah. Okay, good morning, everybody. Thank you for the introduction, Carl. My name is Anja Jacobs. I'm a sociologist, maybe that's also important to know, but I'm almost in the field of human digital interaction, I would call, for almost 20 years. And I think for almost 10 years now, we are doing research on human-robot collaboration. And actually, surgery was my first human-robot collaboration case. It was together with Barco, and it was about this image, about can we organize this operation theater of the future, really wireless kind of communication. And we there studied how, at that moment in time in Belgium, the difference in team collaboration between a laparoscopic surgery and a surgery using the Da Vinci procedure for prostate cancer interventions was going. And how do we do that? We have a certain type of approach that we very much like to understand this trust that was talked about, to understand the benefits and the limitations for all actors, so also for all healthcare professionals and the patient. So starting from what do we know about it's happening today, how are people using it, then enabling people to participate, to think about the future, how they would like to see the future, and then of course test as soon as possible, even with a paper prototype, about this future scenario, about what it means in practice for the people involved. So that's our common way of doing it on different topics, but also on robotics. And if you talk about human-robot interaction in surgery, in media, often these kind of pictures are shown, but as Roberto also pointed out, reality is much more messy. And that's also important to take into account if we talk about sustainability, of course. As also Kristóf in the first presentation pointed out, it's the humans interacting and wanting to change their behavior in, for example, the sterilization challenges that we have. But also, the interaction of all these different components in the operation theater. Now, when we started to think about these sustainability challenges, for me it was Bram van den Borgt who came up with, I read a fantastic paper about sustainability goals and the relation with AI. Couldn't we do something for robotics as well? And so we digged into it, and we went looking into this challenge of these sustainability goals. It is a long trajectory at a world level, with the United Nations taking for many years the initiatives to try to find a kind of common ground between different perspectives, different ideologies about what a good future would be. And these 17 goals are actually put down already for many years. And of course, they have their limitations. But often, when we talk about sustainability in robotics, there's also almost only attention for the environmental sustainability goals, while these others are, of course, also really important. And so today we are talking, of course, about this SDG 3, the health sustainability goal. And when I'm reflecting on my own work, I've been doing almost 20 years of research in digitalization and healthcare, how are we doing with our projects? And then it humbles me always, because the main targets with my digital solutions, I try to make them human-centered, but actually the impact I can imagine is relative to the hugeness of the goals actually that we want to attain. But of course, let's not be pessimistic. Everything counts, and what can we do with robotics? And also in the previous presentations, I think people said there are potential positive impacts, and for robotics in surgery, mainly it's about this higher accuracy of procedures, where the promise, the benefit is of trying to create better kind of robotics there. And so there are, of course, these direct impacts in different cases, and also in robotics. Important always, if we think about sustainability, is also to map out these indirect impacts, both for better and worse. If we focus then, for example, on the SD3 on health, we can say, we have, for example, also was talked about if we were talking about sterilization in surgical robotics. We could use robots to do this sterilization in a better way. On a larger scale about pollution, and we could also use robots to help us to mitigate pollution that we created earlier. But of course, you can see there is indirect positive and negative, because in tussle with the other SDGs. And so actually that's the strength, I think, because it's not one way or there's no one direction. There's always this tussle between those different SDGs and us trying to look for a balance that we can agree on to reach those different goals at the same time. If I think about implementation of robotics more broadly, a thing that I want to point out that's always recurring is underestimation of the invisible work robotics bring with the use, actually. So like thinking about maintenance, thinking about cleaning, storing, training needs are often underestimated. Oh, sorry, I'm going too fast. The comparison, of course, also on a macro scale, the implementation of robotic system in the global north versus implementation opportunities of implementing these kind of solutions in the global south. There's a huge potential increase of inequality we have when we push actually and put all our efforts and investments on this kind of systems. And of course also, keeping ethical questions that are ingrained, I think, in several of those SDGs also at the table, not as a last thought, but actually at the very beginning of us developing this kind of new solutions. Now, bringing myself to, because I have been promising to reflect on a workshop that we held last year in June in a conference on medical robotic surgery. I'm going to present the insights that we captured there to continue actually this discussion in this plenum, but also in the idea of bringing that further. But before I jump into that, I thought like, okay, let's check also like, okay, what systematic reviews offer us? And those are 3 reviews I consulted. Of course, a systematic review and bringing reviews of reviews together, it makes it very high level and abstract. But what you can see there is that, again, there's a lot of attention. Actually, there's no attention to the social sustainability goals, to the economical related sustainability goals, to the collaboration 17 SDG, for example. There's no attention there for that. It's focused on the environmental aspects. That's necessary, but it's not the only one. So for me, that's very apparent, actually. And there's also no differentiation. Surgical robots are presented as one system and not as separate systems where some parts maybe are easier to increase the sustainability of the system versus other parts. So that's also something I noticed when I was going through those reviews. A big thing is about, and I think Roberto also pointed at that, it's like, it shouldn't be a tool used for everybody. There's a high cost, there's a limited evidence about the impact for the quality of care and efficiency. It depends very much. So we need to be very aware for which type of patient this is the best solution. And actually that's where we're still struggling a bit, I think, with insights. So we did this workshop. And there was a lot of competition in other workshops. And so actually, we managed not to reach a lot of people. There were only 5 people that actually subscribed to the workshop. We had room for 30. What does that tell me? It tells me there was competition that was more interesting at the conference and that it's also still having a very low relevance for that community. But I was very happy with the discussions that we had. There were some people with some medical background, but also product developers of new robotic systems present in the discussion. And of course, we as well, like Kristóf, we took part in the discussion at hand. So what did we learn from this kind of brainstorm co-design? Which ideas popped up? The first one was, of course, we asked like which SDGs, as we asked today, which SDGs were really, for you the most important, are in priority if we are going to discuss the sustainability in surgical robotics. And then there was already this discussion, and you also chose SDG 3 as a priority one, but then there was this discussion like, okay, is it about, is it more important that a person gets the best treatment without the consequences for the whole society? And so isn't a medical issue always more important than having it green? Like, is the life of a person not always more important than making it environmental friendly, for example? So from the very start, some very interesting discussions, and also this reflection on the fact that for certain less popular challenges that we rely a lot in our society on kind of foundations to actually where the market is failing, trying to mitigate that point of attention. Then, of course, there was also in this group a lot of attention for this environmental sustainability. And a first one was really fundamental about the materials used, the materials used in the robots. That it's really hard actually to get away from it also, and that will pop up a lot in the discussion. Some regulation, healthcare is, of course, a very regulated playing field, and so there are some limitations in your exploration, in your innovation. So sometimes it can be questions like if biodegradable material is always necessary. For example, that was one of the arguments that were brought. And again, you see like we had before, like can you green versus quality of life or quality of procedure? Can you do the trade-off? And here again, it's this question of can you do the trade-off between safety and the environmental impact of the material. Again, then there is this question. So at one hand, you see the demand for more regulation, and at the other hand, you see like, okay, but the regulation we have is not good. So you see this build-up also for like some different type of regulation. Then it was not only about the material use, but it was also about how to recycle those specialist parts. That's a real challenge. And there, sterilization popped up also. We also in the prior in the first presentation of Kristóf, it was about sterilization. And here it was like, electrical devices currently, for example, batteries are not allowed, although they can perform longer. We built them for that, but they aren't. We can't reuse it. And then the challenge was like, there are different. It's not that engineering needs to invent new sterilization techniques per se. There are solutions, but they are not regulated. And again, this regulation challenge popped up very quickly, actually, in the discussion. And so, that brings us then to a next list of SDGs that were discussed a bit related to each other. And of course, that's about the economical layer. You have to have, how do we do responsible consumption and production? How do we do innovation? And how do we actually organize ourselves to have better partnerships on these goals? And so, actually, they said themselves, like, it's a very well-budgeted field, surgery. Also, most robotic surgery interventions, they are planned. So they are not allowed also. Again, there's an issue also of regulation in an ER environment, for example. But the field, how it's organized economically, there's a lot of lock-in. There's a lot of non-interoperability. I think also Roberto showed examples for his speciality, where this challenge of the lack of interoperability is really keeping us away of using robotics in a sustainable way in a hospital. And there's actually also this lack of competition. And Kristóf referred to that, I think, with saying like there is this movement in coming more companies offering solutions. So there's also more competition on trying to solve the same problem. So again, there it's we should come together. We should try to work out some strategy, some planning to solve this kind of challenges. Then another issue in relation to these SDGs were like the basic materials, that it's really hard to get the right, if you're innovating, if you are the product developer, it's really hard actually to have the right new component because there is this scarcity of basic materials, and because you're also making something that's on average, it's not a mass consumable. So there you have this challenge and delays in development time, which are challenging and which also keep you actually not innovating that much. There's also, in the planning, there's also not a standardized surgical planning, and that's also giving them less opportunities also to, align with the robotic system. Then, of course, robots in general, they are not as mobile, and we know that innovation travels faster when things are mobile. So it's also more difficult to make it integrated in different settings. Also, they mentioned that in the surgical robotic field, it's still not very agile. It's still working very much in the waterfall kind of way. I think it's also related to these longer leading times of design and also the lock-in that we had for a long time. And then, there's a lot of regulation. And so different certifications which ask a lot of investment and which also keep startups from trying things out. And the last topic that popped up in the discussion was about education. What the typical also question about when you robotize things, people do not need the skills they have today, and isn't there the risk of losing those skills? Also the use, and that's not really robotic, but the use of VR with artificial intelligence to organize trainings in a virtual way instead of a training in real life. And what are we going to lose with that were questions that were raised, as well as like a very small thing, but I thought it was also illustrating like what can come out of this kind of co-creation workshops, a reflection about dexterity. Couldn't you design actually for a standard test for dexterity so you can know earlier from a physical point of view who would be the right surgeon or not. Now, we tried also to come already to solutions from those ideas. They are very drafty. So the first thing where people wanted to think about was this access to material. And it was like, okay, shouldn't we get, instead of having the chips going for a kind of toy or a kind of consumer electronics, shouldn't those basic components come first to medical devices? Can we help to mitigate that access problem? Also, like production in Europe, I think with the CHIP Act, etc., Europe is already trying to invest more in this basic material challenge. Then recycling of parts. Then there it was like, okay, can we not, for example, in proposals of the European Union put sustainability as a requirement more systematically, more well described? And the question like, can we think about how we can make VCs also more caring about the sustainability aspect, so it's also creating this interaction in our product development. Then the last thing where a lot of attention was about was on this regulation, a more efficient regulation, but yeah, this trade-off, this challenge of this trade-off, and there were ideas about public-private partnerships, so you can also create more sharing of knowledge about how to do things better, and also like trying to put things into the development of standards. So those were preliminary ideas. So where do we go from now? I think we need to keep talking about the tussle between the SDGs very much. And personally, I hope we can continue this conversation, organize different workshops with different parts of the target group in relation to surgical robotics, and start up also some initiatives to try to overcome the identified challenges. So thank you very much.
Thank you, Anne. So I was made aware that if you have questions, please don't hesitate to interrupt Anne during the coffee break, but there is also an important message that you need to convey. Okay.
Okay, welcome back. I hope at home you also had some nice coffee and had some maybe some conversations with other people. We had a nice discussion over this coffee break, and let's continue this conversation. And therefore, I want to introduce Koen Beijers, who studied at Utrecht University and is currently also founder of Voxdale. And he is talking today also about IDEVAX. It's one of the medical devices they developed, and IDEVAX, a vaccination robot. And he will talk today about the role of sustainability in their company. So welcome, Koen. Happy to hear you talk.
Thank you, Professor Jacobs. I've got some good news. The medical robot market is growing rapidly with a compound annual growth rate of almost 17%. And it's growing in all segments. Diagnostic robots that you would typically see in labs, interventional robots, eye surgery, radiosurgery, knee and hip replacements, neuro and brain surgery, spine surgery, abdominal procedures, throat surgery. I think you get the point. Rehabilitation robots. This one is growing really fast. Physiotherapy, gait and walking training, hand rehabilitation. In most cases, straightforward development, I could say, as designers can start from existing robots and cobots. So there's an opportunity. And I think pretty much in the same field, robots supporting patients, robots supporting healthcare professionals. So this will be a 76 billion market by 2030. For comparison, the total prophylactic vaccine market will be 100 billion by 2030. So robots are going to surpass the vaccines market before 2035. I guess with this audience, you've all seen these type of images, diagnostic robots, surgical robots, more messy in real life, as Professor Jacobs pointed out. Rehabilitation and physiotherapy robots, as you can see, they are very often based on off-the-shelf robots. Not to be disrespectful, but it's an opportunity to do fast developments in that field. Briefly about myself, I'm Koen. I have an innovation background. I was founder of Voxdale back in 2007 with a main focus on hardware innovation, but on robotics as well, among other industries in medtech. I was CEO of Voxdale until 2020. In 2013, I was founder and CTO of Novosanis in the diagnostic field, more precisely first void urine sampling. Novosanis was acquired by Orashow Technologies back in 2019. And therefore now I'm CTO of IDEVAX, active in the field of drug and vaccine delivery. I just made a comparison with the vaccine market. Is there a possibility that in the future we will get vaccinated by robots, by a robot called Robin, for instance? I think it's clear that vaccines in itself have proven to be a worldwide success. According to WHO, 400 lives are saved each hour thanks to vaccines. That's about one life every 10 seconds, saved from dying from measles, polio, rabies, flu, COVID, obviously. 150 million lives have been saved over the past 50 years. Additionally, you would think that since COVID, we've become pretty used to vaccines and vaccination as a procedure. But vaccine hesitancy never has been higher. Coverage is dropping, and there are plenty of reasons for that. At the patient side, with a lot of disinformation, to be honest, but also at the healthcare providers and in the industry. Things like needle phobia, the need for physical distancing during the vaccination, overloaded healthcare professionals, the risk for needle stick injuries, not the least the time and the costs to develop vaccines and produce them. I think upscaling proved to be a major challenge during COVID. A very important element in the light of today's topic, I think. Producing one dose of vaccines generates approximately 200 grams of CO2. Tens of billions of vaccine doses are produced on a yearly basis. In an effort to unload healthcare professionals, countries and governments are shifting the line of first care to the pharmacies. Last autumn, in Belgium, you could visit your pharmacist to get your flu and your COVID shot. And by now, at this stage, 15 European countries have taken similar decisions, and more will follow suit for sure. 9 countries even allow additional vaccinations or vaccine administered at the pharmacy, for instance, vaccines for rabies. Could this be an opportunity to tackle some of those issues that I just mentioned? Or do we risk, in the wake of unloading healthcare providers, we will start now loading or overloading, I should say, the pharmacists? Could there be an opportunity to be more sustainable in that process? We believe there is. In the pharmacy of the future, that's like a hot topic right now, RobID could help solving these challenges. We've been working with Foxdale, with IDVax, on RobID for quite a while now. This is a picture of the early developments. And I'll explain how it works and show you the customer journey in a short movie. As I said, vaccination is shifting more and more to those pharmacies, with the pharmacist basically getting an extended role in a healthcare providing team. And as I said, this could overload them. And that's the opportunity we would like to tackle with a development like RobID. The initial development was supported by Europe and VLAO. And our solution works with VaxID. That's a device that allows for skin delivery of vaccines, not in the muscle, because compared to vaccination in the muscle, skin vaccination only requires a fractional dose of about 1/5 to 1/10 of the dose given in the muscle. This favors more vaccine availability when vaccine supply is constrained, obviously, or under pressure. For instance, during pandemics, as we've seen, not to mention the saving on carbon footprint with that. Banking on accuracy of robotics even magnifies that effect. And additionally, the robotic solution can relieve the burden put upon the healthcare professionals while safeguarding the physical distancing we often need. There's also less need for excessive personal equipment, which can be a shortage as well. For the vaccinee, the robot can administer a pain-free vaccine in less than 30 seconds. While the aim of the design and the full user experience is there to minimize needle and robophobia, an important topic as well. And the goal is that with a future installed base, large populations could be immunized in a matter of just months. Some of the features, you could see a tray that holds the vaccines. There's an armrest to stabilize the arm. There's a robotic arm to manipulate the device. And there's a sharps container for waste. And of course, a user interface for interaction with both the patient, the pharmacist, but also with the medical data in the cloud. The procedure looks like this. So the patient enters a pharmacy with their EID, which can, for instance, include a vaccine prescription. The robot will be preloaded with a tray containing a number of those fractional doses, 1/5 to 1/10. The system, as I said, taps into cloud-based patient records and electronic data. So upon approval, the patient just have to roll up or unsleeve their arm, put their arm in that armrest. The inflatable will expand, will stabilize the arm. And then there's this good reference plane that allows the robot to administer a very small dose in the skin of the vaccine. It only takes a few seconds. It goes really fast. Once that's done, it's about 1 millimeter deep, by the way, so very shallow. After that, the inflatable will deflate. The patient is basically dismissed, and the device is then disposed into the sharps container, after which that robotic arm will select a new dose for the next patient or vaccinee. And of course, there's a lot in the pipeline to develop more variants and more use of RobID. I always add a few pictures in presentations. There's a 60% chance that PowerPoint movies don't work actually when you're in front of an audience, but yet it did. So this is the current stage of, or the current state of the development. And here you see the patient arms nicely stabilized in that armrest, and the device just on top or above it before the administration of the vaccine. We've been filing 5 patents on the system, on the tray, the inflatable armrest, the device delivery, and coming back to the dose sparing potential I just explained, with the very high immunization capacity of the skin, and the fact that we can give a very extreme accurate robotic injection. I think dose sparing is probably the most important asset of all the challenges we have to solve. You literally can save 80 to 90% of the carbon footprint of that entire procedure, where you only need 20 grams basically of footprint compared to 200 for a standard full dose intramuscular vaccination. Within the company, of course, we have a sustainability strategy defined in a number of scopes, and that's ranging from reduction direct emissions from operations, from the equipment we have, from travel, to energy consumption, the electricity we source and where we source it or generate it. Also the footprint of producing our own devices. There's injection molding technology very often involved, of the equipment like a robot. But again, the main impact is very often on indirect emissions. In the value chain where you basically develop for. If we can move pharma from full dose to a fractional dose of 1/5 to 1/10, sustainability gains could be huge. As Professor Jacob pointed out, sustainability goal 3. With this, you could have more vaccine availability, and with that, more access to vaccines. And I truly believe that there's a future for solutions like RobID in low and middle income countries, where I could see vaccination hubs that are installed with a system like this, where there's not a lot of trained healthcare providers, then solutions that are autonomous or semi-autonomous could be a big asset for a very accurate low-dose immunization. The development is ongoing. We are doing now some usability, acceptability tests. We do that with imec, with HitLab, University of Ghent, where we are looking into acceptability, anxiety, how people, there's still a robotic arm in front of your eyes. How can you avoid that you are switching needle phobia with robophobia? It's a very important topic I would love to discuss. We did a demonstration at Supernova and Flanders Technology in Sportpaleis in Antwerp. We had 500 people doing this procedure with a dummy device. We didn't use any needle. Result was surprisingly very positive. People who really believe that this could be the future. Could be a bias because I can guess people coming to these type of events have some interest in technology. But yeah, we are working on our development, on the industrialization of it, preparing the upscaling. As always, we are raising money to execute on that go-to-market. We're talking to venture capitalists, and for sure looking forward to partnerships, things we could do together to move projects like this forward. So happy to hear your questions and happy to give feedback. Thank you. Any questions?
Thank you, Koen. This was very interesting, and it's also good to see someone from industry talking about these issues. So I have some questions and also suggestions. Are you aiming perhaps also countries like in Africa or in India, where there are huge numbers of children also to be vaccinated. If this is yes, then my following question would be, are you still able to change the design or put some extra things on the design? Because I think it could help the perception of children, how it is perceived.
Yes, yes, we are. We are focusing very much on children. We got a request from Patrick Soentjes from Institute of Tropical Medicine to do a rabies trial in children. We at 3 p.m. I have to enter a grant application for cross roads to basically start tackling the topic. We did some dummy tests with about 100 kids between 4 and 12. Feedback was really good. They kind of like it. There's an opportunity as well to do that customer journey really well. You've seen we have the screen. How can we add to the story? How can we explain what we are doing, or how can we distract them? That's from a procedure point of view. There are some anthropometric challenges. So the design we have now is for adults, like the forearm length, circumference of the arm. We have an inflatable, but it cannot tackle everything. So the way we are now approaching the project we are submitting today is indeed how can we optimize or make that armrest modular to indeed accommodate children. With regard to developing countries and low and middle income countries, yes, for sure. All you need is electricity and preferably an internet connection to access the cloud. It would be an accessory to a medical device. So the injection device is a medical device class 2A. That's like any needle or any syringe, basically. The device would be an accessory. The robot itself is just an accessory, which sounds a bit funny, but it is. And I think that opens an opportunity to indeed have your operators, because that's how we call them. This would never be a fully standalone. I think for adverse events during vaccination and so on, you need a healthcare professional or a healthcare provider or a caregiver or an operator in this case on the spot. So that would minimize training. Additionally, one of these operators could perhaps control 2 or 4 of these machines. So it's a topic that's on the radar, and I think there's an opportunity. We're gonna also check with the parents, because it's often the parents that would guide their children through a procedure like this.
Yeah, I think there are some ethical issues around it as well. Who is the responsible person? What if something goes wrong? I mean, these are all risks. I may have some follow-up suggestions around the topic as well, but I will give the chance for other questions. I will see you around.
Okay, thank you.
Well, maybe someone else wants to ask a next question. Maybe the next speaker can already connect his laptop. I see 2 questions.
Quick one on the certification process. How long do you think will take from the moment where you have a solution until you have it certified?
Well, we've gone through this process before quite often. It's an accessory. So the set of technical documentation is overseeable. We also have some additional development and upscaling engineering to do. So the projection we see now is it could be in about 3 years from now to have it to have it CE marked in the first place and FDA approved in a second phase, so it can be commercially available.
This question might be not in your scope, but I was just interested. You said you need less vaccine if you use it with the robot. Do you know why? I was just wondering.
I'm not medical trained, but I think I know. I can try to explain how it works. So basically, when you get your vaccine in your muscle, the lymphatic system has to get the vaccine into your immune system, and a lot of that basically is lost because of that. The skin is highly immunized, lots of dendritic cells. So if you can target the skin, which is very, very shallow, it's about 0.8 millimeters, and you can guarantee that you have a very controlled injection in that layer, That's why you only need 1/10 of that same dose intramuscular to trigger a same immune response, to have a non-inferior result compared to the intramuscular injection. This has been known for about 50 years. The first publication about that are very old, but it's very difficult to do that with a standard syringe and a needle. Because you have to inject under a very shallow angle to lift the skin and try to, it's called the Mantoux technique. It's a very old technique. It's very painful, it's very difficult, because if you go too deep, you go subcutaneous, and then basically the vaccine is almost lost as a whole. The opportunity to have a device like VaxID and to have the robotic accuracy to execute on that is an opportunity to use that intradermal technique as a dose-sparing solution.
Thank you very much. Let's give one applause to Koen Beijers for his talk.
Thank you so much.
Okay. So thank you very much. And then let me introduce very shortly Dr. Nicola Frego. Today he got his training in Italy, Milan, yes. And then you got a very nice experience, I think, also in the United States, yeah, also in Boston, but today you are also part of the robotic team at Onze Lieve Vrouw Aalst team, and last but not least, the director within ORSI, the academy, where we try to get enough people trained in a very skilled way, and so you're also overseeing the training programs. Yeah. So very happy to have you here, and lovely to hear your talk.
Thank you for the introduction. So I'm Dr. Nicola Frego. I'm a urologist and the Deputy Medical Director of ORSI Academy. For those who don't know what ORSI Academy is, we are talking about a training academy focused mainly on robotic surgery. And the goal of ORSI Academy is surgical innovation and robotic training for novices surgeons. So we are living in a world where robotization, domotization, artificial intelligence play a crucial role in many areas of our lives, and this is also true and happening in medicine. The milestone of robotic surgery is the Da Vinci system, and since the approval of the first Da Vinci system in 2000, 4 generations, 6 different versions of this kind of system have been approved for the use in many specialties. And although in 2018 many of the patents of Intuitive expired, the Da Vinci is still by far the most widely used robotic system in the world. Here we have a representation of the widespread of the Da Vinci system around the world, with the more than 7,000 Intuitive platform installed in more than 70 countries, more than 10 million of procedures performed with the Da Vinci system each year, and a lot of scientific publication regarding this kind of technology. However, we are assisting to the birth of a new era in terms of robotic surgery, with a lot of companies that are trying to develop and put on the market their own system, like Medtronic with Uberast, which is already an important reality in this field, but also CMR with Versus, Medicaroid with Inotori, and many others. Speaking about sustainability in robotic surgery, we must focus on 3 main aspects, which are the economic, the social, and the environmental sustainability. Starting from the economical point of view, the global market for surgical robot has constantly grown over the last 20 years. And just to give you some numbers, in 2022, it was the market of robotic surgery system was valued $4.4 billion, and it is expected to expand and grow with a compounded annual growth of 18% between 2023 and 2030. However, when we speak about cost of robotic surgery, is very important to analyze this aspect under a micro and macroeconomical point of view. For microeconomic, we refer to the cost relative to the increase in market size and demand, the high cost for the robotic system, instrumentation, and maintenance, which lead to high cost on patient and hospital level. However, on the contrary, under a macroeconomical point of view, thanks to the advent of robotic surgery, we reach shorter hospitalization, less complication, better outcomes, increase hospital caseload, and lowering in this way the cost for the healthcare system. Here we have some publication which analyze these topics. For example, comparing the cost effectiveness of robotic surgery versus open surgery for kidney surgery, oncological kidney surgery. We have robotic surgery allow shorter hospitalization, lower rate of postoperative complication, resulting in a lower average cost per patient. Here again, we have an important study published on JAMA, focusing on the comparison between the cost of robotic versus open radical prostatectomy in the US healthcare system. And the conclusion of the authors were that RARP, so the robotic approach, has a higher cost at the index hospitalization compared to the open surgery. But after 1 year, the cost of the robotic approach is cheaper than the cost of open surgery, and this because the reduction in the use of healthcare system for robotic approach results in a saving of around $3,000 per patient, with also less days lost at work in terms of postoperative recovery. However, in the Western countries, the robots are mainly based in the tertiary hospitals, so it's not still something that we can have access in all the hospitals, neither in the more developed countries. And the main reason of these barriers, according to a survey published recently, were the high cost of the equipment and the high running cost. Luckily, we are going to live a new era of robotic system in terms of market, because the reason of this high cost of initial at the beginning of the robotic experience for many hospitals were due to the monopoly of Intuitive, which was the only company selling the robot for surgery in the past 20 years. Luckily now the patents of Intuitive expired, and in this way we have a lot of other companies that are going to produce their robot, increasing the competition of the market, and in this way lowering the price. Under a social point of view, robotic surgery has brought to shorter hospitalization, faster recovery, and faster return to normal activity, with a direct impact on society. The advent of robotic surgery improved the precision and the quality of the surgery, and in this way also the functional and oncological outcomes. Here we have a systematic review conducted on more than 1 million of patients with a comparison between open laparoscopic and robotic radical prostatectomy, and the authors conclude that we have a an advantage under an oncological point of view, but mainly under, I mean, the main difference were found in terms of length of stay, blood transfusion, blood loss, complication, and many others perioperative outcomes. This improvement in perioperative outcomes have a direct impact on the society with reduction in waiting list, allowing for greater turnover of patients and better utilization of the healthcare system resources. Here again we have a study showing that robotic surgery, with its less invasiveness and lower complication rate, allows a faster return to everyday life, with fewer working days lost due to illness after surgery, with an undeniable social and economic impact. Moreover, robotic surgery is the key for moving toward a smart and intelligent surgery, with the possibility of guiding surgical performance, advising surgeons on the best approach in individual's patient, and many others possible applications. Again, another advantage of robotic surgery, with an important impact on society and especially in terms of training, is that the learning curve of robotic surgery is actually faster than the one of laparoscopy or open surgery, with a direct, obviously, effect on the cost for the training of the new surgeons. Although all these advantages, all these main advantages, robotic surgery is still considered an elitist medicine reserved for Western countries. So there is a huge disparity in access to robotic surgery around the world, and the main problems to its implementation in low middle-income countries are the high running cost, shortage of surgeons, lack of training, and network issues. However, the incorporation of robotic surgery in these low middle-income countries has several potential benefits. First of all, it could reduce the surgical side infection and antibiotic resistance, which are one of the main still one of the main cause of death in these countries after surgery. It could allow to shorten the length of stay, with a dramatic impact on the healthcare system of this country, where the hospitals are overcrowding, posing a significant barrier to accessing the care for many patients. Then we can have advantages in terms of telementoring and telesurgery, which is a very important aspect of robotic surgery, solving the problem of surgeons training. And overall, all this kind of advantages, potential benefit, can reduce the gap in terms of access to healthcare and quality in the healthcare between Western and low middle-income countries. Looking at the environmental sustainability of robotic surgery, why robotic surgery brings numerous benefits, a lot of benefits in terms of patient outcomes and recovery, its environmental impact cannot be overlooked. In particular, the environmental footprint of robotic surgery are focused on energy consumptions. Robotic system required a significant amount of energy to work, and high energy consumption contributes to the carbon emission and the environmental strain. Then we have resource utilization with the production of a robotic surgical system that requires rare and valuable resources. Then we have waste generation because of the disposable component used in robotic surgery. And finally, but not least, the transportation, because the robotic surgical system often requires specialized transportation, and the logistic and shipping contribute to carbon emission. Here we have a systematic review regarding the sustainability in robotic and laparoscopic surgery. And the main findings of this systematic review are that the production of disposable and anesthetics were the main contributors of carbon emission in robotic surgery. Comparing to other approach, robotic has a higher impact in terms of production of carbon emissions, CO2. And with a 24% higher waste production compared to other type of approaches. So it's very important that manufacturers and robotic surgical system manufacturers of robotic surgical system must prioritize the sustainability in product design by incorporating eco-friendly materials, optimizing the energy efficiency, and designing the robot in terms of a better recyclability and reusability. Here we have some examples of virtuousness, like the Cleveland Clinic that has implemented a greening operation room aimed to reduce the waste and energy consumption in surgical procedures, including those utilizing robotic surgery system. Also Intuitive, which is the most important company producing a robotic system, has taken the pathway of sustainability in terms of product design by incorporating eco-friendly materials, optimizing the energy efficiency of their system, and designing for more reusability instruments. To conclude, we can say that robotic surgery is an irreversible pathway with benefit for patient and society. The high running costs of robotic surgery are still the main problem in the widespread of such technology. The increased competition will lower costs, enhancing a more equitable use of robotic surgery worldwide. And robotic surgery has the potential for moderate cost advantages for payers and society over a longer time horizon. Finally, environmental sustainability of robotic surgery must be a priority. Thank you.
Are there questions in the audience?
Thank you very much for the presentation and the very thorough look onto the environmental perspective and like the overall sustainability dimensions. You said there's a higher environmental impact with robots, and you said also at the end that it is a priority to push that a bit more and like decrease the impacts. Do you, or maybe like from your opinion, do you see this happen in the future? How positive are you that we can achieve actually a decrease, that we can arrive at a positive environmental impact?
So I can give you a direct answer to this question. The sustainability, the environmental sustainability, is not topic for this moment for all of us. And this is true also for the companies. Okay, so we are living in a situation where there are a lot of coming up companies with they try to develop a new robotic system. For some kind of companies, it's difficult to implement a technology like this one with focusing also on like the green aspect of the production. But there are also different companies, the most actually important, like Medtronic, like Intuitive, which are investing money in this kind of project. Okay, so there are engineering, there are entire unit of this kind of company that are working on the sustainability under an environmental point of view for the new system that are coming up. Okay, for example, the last version of the Da Vinci, the Da Vinci 5, which is not already in use in Europe because we are still waiting for the approval by the CE mark for the use in clinical practice. But differently from the previous version, this kind of system will have a battery that consumes very, 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 very low energy in comparison to the other system. So this is something that this is a good start point. Also, they try to improve the life of the instrument because, for example, the instruments in robotic system you can use for no more than 10 surgeries. Okay, they are trying to increase the life of the instrument, and it's something that is feasible. It's already ongoing. So there are, I think, a lot of road to do under this point of view, but I think that also for these companies and for this field, first of all, I mean, we are trying to going in this pathway, but the road is still not so well. But
you have
you also mentioned the need for raising the awareness with patients and surgeons about it, and I was wondering, like, because ORSI is a training, it's really oriented at training. What are you already doing? What are you planning to do to create this larger awareness on the topic?
So in ORSI Academy, obviously all the system that we use are systems that are the one that we normally use in the OR, in the hospitals. So we can't develop a system in a more eco-friendly way. What we can do is to sensibilize, obviously, customers, companies who are working with us and are using our facility, our instrumentation about this topic. But under a practical point of view, our role is just to make aware people about this problem and try to implement together with the companies possible solution. But yeah, it's not the goal of ORSI Academy to try to guide the green moving for the robotic companies. The only things that we can do is to try to push under a social point of view the green transition.
Maybe I have a. Oh, I see. Not one more. We have time, so I will give her.
Thank you, Nicola. This was a nice presentation, hearing the perspectives from the ORSI as well. I was wondering, maybe you have mentioned it. I'm sorry if I missed it. Are there any comparisons between the sustainability performances of the robotics surgery versus traditional open surgery?
Yeah.
Okay.
No, sorry. Okay. You. Okay. So okay. Sorry. Yes, there are. I think that I showed in the last slides of my presentation a couple of studies that directly compare the impact in terms of carbon emission and waste production between different type of surgical approaches, in particular between robotic, open and laparoscopic surgery. Robotic surgery has an higher impact if you compare, under this point of view, if you compare it to the laparoscopic surgery, because we are going to use more energy, we are going to use more instruments, we are going to use more we are going to produce more waste. So obviously under this point of view, robotic surgery is still less green than other type of approach. Okay, this is undeniable. But it's also true that it's a big advantage for patient and for the healthcare system in general. So we can't go back to old type of surgeries. What we can do is try to make it feasible under an environmental point of view, trying to reduce the amount of energy that we use, the amount of waste that we produce in each robotic surgery. So yeah, it's less green than other type of surgery. This is undeniable.
Maybe I have a question now myself. So many years ago, Anja and me, we studied people in operating theater using robotic surgery. We also observed one of your colleagues, Dr. Moitri, who is also in ORSI. And what I remember from setting it up is that you have you wrap all the arms and you get the head, all the instruments, they have only a certain number of lives, and then you have to replace them. And this was for the Da Vinci robot. So I have not been focusing on surgical robotics that much in the last year. So I was wondering, like with the new surgical robotics that are coming up into the market, is there a difference in how they are used? And in maybe also in terms of sustainability, are there some differences, or are they very similar to the Da Vinci robot?
Actually, they are very similar. Under this point of view, they are very similar. So we are still using the drape of each robotic arm. The instruments of the intuitive, the Da Vinci, now in comparison to some years ago, have more life, so more possibility to use for many surgeries, and is good under this point of view. But there are also other companies like Medtronic with Hugo that are using a disposable instrument.
Okay.
And I think that this is this disposable instrument has a higher impact on the environment than a reusable system. Even if they say that they try to recycle the instrument, but by the way, the amount of waste that you just produce for one surgery is greater than the Da Vinci one. So the situation is not changed a lot, but my opinion and my view under the situation is that the new companies that we will see, the new robot that we will see in the next few years, they will probably try to focus more on this kind of problem and reduce the amount of waste that they produce in terms of draping, in terms of instrument. So, yeah.
Thank you.
Up to now, there is no big update under this.
Maybe then a short last question, but it was more about training. So is it faster to train into one surgical robot system or in another one? Do you see some differences there? Because I saw on your slide between robotic assisted surgery and laparoscopic surgery, I think it was the other. There were a lot of differences.
So the learning curve for robotics, for robotic surgery is shorter than the one for laparoscopy and open surgery. There are a lot of studies that actually have this kind of findings. The real advantage is that the robotic system, when you start to use one robotic system, the transition between one robotic system to the other is very easy, okay? There is not so many difference in terms of console use for surgeons. So this is obviously an important advantage of robotic surgery. But yes, the learning curve and the way in which we train the new surgeons is totally different in comparison to what we were doing for laparoscopy and open surgery. Also because robotics allow us to standardize the procedure, to standardize the training, and when a procedure or a type of training is standardized, is also easier to reproduce this kind of training, not also in Orsi, but in every training center in the world. So it's for sure a big advantage.
Okay, thank you very much. I would like to thank you for your talk. And then we take like maybe 5 minutes to set up the panel, and then we'll be back in 5 minutes.
All right. Thank you all for being back. And it's now my pleasure to have and animate a little panel discussion with the previous speakers. So thanks for participating to that. I think my first question will relate to how complex it is to, of course, bring a cutting-edge technology into healthcare. And one of the aspects that is challenging is that on top of the ethical challenges related to the technology, when you come with the new technology in healthcare, it's a highly processed environment with a lot of rules, deontological rules, and it's quite hard sometimes to navigate when you're also, for instance, a company or someone outside of this world, to understand that in healthcare, whether it's related to professions or hospitals or institutions, they have already a lot of deontological rules or strict standards that they have to apply to. So my first question to all of you would be, what do you think is a specific challenge that robotics can bring, a new challenge that robotics can bring to the field of healthcare? Because even if there are a lot of rules, maybe robotics will bring something that current rules do not envision for now. So maybe let's start with you, Kristóf.
Thank you. Can you hear it? Okay. So yes, it's for example the first step, I think, or well, not the first, but a big step in this direction was that KUKA LBR robot arm that, for example, as a robot arm is a medical grade robot arm, can be washed, can be sterilized. However, you of course need to put something on at the end of the robot arm and end of arm tooling, which is then your responsibility to make medical grade and to be able to prove that it's a medical grade device. So I think it's the same problem as with collaborative robotics in the industry, that okay, a robot arm can be collaborative, but a robot arm with a tool is a big question if it's collaborative. So I think one of the biggest challenges is probably this, that how can you, well, according to the old and really to the standards that are really difficultly and really slowly can be changed, how you can push your new and possibly more sustainable or possibly in any case much better ideas into this slowly changing and really slowly accepting system.
Thank you. Anne?
Yeah, I think what's different, I think mainly also looking into non-medical applications to support in challenges where the healthcare system is suffering from, like for example, logistics. There are many industrial solutions already available, robust, tested. So like also trying to find a good equilibrium in the use cases that are also in healthcare situations there in hospitals, but also outside hospitals. That's one, I think, that could be new. That's not so much there, although yeah, you also have like medication delivery kind of solutions, etc., etc. And I also think we agree that people want enough oversight. We see that in the surgical case, and I think everybody thinking along with that also wants that professional, trained, having this right, making this right decisions. But I think the challenge also for the future and robotic systems to make the best use of it, it's like what tasks can be automated and where do we need another type of oversight to make best use of that kind of system, taking into account all the things we said about sustainability, of course.
Thank you, Nicola.
So I think that the collaboration between healthcare system and companies could be the real key to try to improve this environmental transition also for robotics in general. I'm talking about robotic surgery, but could be every type of robotic application in healthcare system. So yes, the collaboration between hospital centers like Orsi Academy and the companies could have a an important role. I think that also the regulation under a European Commission are very important in terms of guiding the development of the new robotic system, because up to now there are no many strict restrictions in terms of eco-sustainability in robotic surgery, for example. But I think that is something that should be faced and improved in the future for sure.
Thank you. One challenge that we see outside of robotics, for instance, in AI, is that sometimes people might have, I think, not the right expectations toward what the technology can do for their own environment. It's either sometimes perceived as a magic wand or as a fix for a problem where maybe things were not done, the simple things were not done prior to that. And so one challenge maybe regarding that is that maybe people could see robotics as a fix in a context where in healthcare, in a lot of hospitals, let's say in Belgium, maybe there is already money lacking or personnel lacking or there is resources lacking to provide a proper care. So it can be a complex situation and context around the implementation of robotics. I had one question more regarding the how do you get people, let's say with you, start with you, Nicolas, how do you get people to maybe be aware of the sustainability challenges related to a new robotic solution, for instance? Because on top of all the rules, there is ethical fatigue or standard fatigue. There are already so many things to take into consideration. So how do you get people maybe in teams or in the settings that you work to maybe start considering sustainability on top of everything?
So this is a good question, and it's something not easy to do. I'm honest, because it's also in a healthcare environment, like in hospital. I think that is not the doctors or nurses or patient that could that should pay attention on this kind of sustainability in terms of environmental, economic, whatever. But I think that there should be some specific organs, some specific offices that they could have the main goal as the main function, this kind of problems, try to resolve, to face at least this kind of problem. But I think that is not a matter of patients or people to be, I mean, we are all aware about the environmental problems, and I think that is a logic that a production of a robot or the instruments has an impact in terms of environmental pollution in general. So I think that is not a matter of society to be aware of this kind of problem, because we are already aware. I think that the next step is to create a specific organ, specific office that face and try to regulate this kind of situation.
Thank you. And Anne, maybe from a methodological standpoint, you know also how to bring people, you know, around the table to also get this conversation started. What would be your thoughts on this?
Yeah, I was thinking about your first question to Nicolas. When I was reading up also in preparation of today, one of the things that I found was a green checklist developed in the UK, I think. Didn't have the time to look into detail, like how much is it used also. So there I'm thinking like from adoption point of view, we know if you relate to practices people already have. So in an operation theater, if I stay with that case, people are used to have checklists to create quality and safety. So can we add some elements in it? So its current practice is not this additional ethical list. But of course, you always have this more fundamental problem about the basic production. That's not solved with that. It's only a small amount, but I think maybe there are some ways to, with small parts, create this daily life kind of things that you can control and that you can add to. I think we need, to come to your second question, we need to open this discussion. I think this awareness involving this ecosystem, where my participants of the workshop were referring to involving it in the discussion and in, okay, what kind of problems can we solve in that way, and really trying to make a joint strategic plan on that. I think, we have the opportunity to start that kind of discussion from this community and trying with the partners that we meet, try to increase the amount of people contributing to that conversation.
All right, thank you. And for you, Kristóf, maybe can you give us an insight of, in an engineering department, building systems around these robots? How does the topic of sustainability come about? What are some of the challenges that you could maybe express when you are working directly, with these robots, trying to make them more sustainable?
Thank you. It's interconnected with the previous two questions, because our biggest challenge is that, of course, as researchers, as a university research center, we can basically research whatever we want. So if we say that, okay, we want to go towards sustainable robotics, we can do that, but we won't be able to get real financial support from companies, from EU-funded projects, until those companies or until EU won't be serious about this problem. And at this point, I need to contradict a little, or not contradict, but add something new. That okay, I agree that we are most of the population is aware of something is happening with the environment, but people tend to say that well, it's happening. It's about Amazon. It's about Microsoft. It's about the U.S. military. They are the big guys in this, the bad guys in this manner. And what can I do? So I think until we don't change this, that yes, we can, as individuals or as scientists or as any group of people, until we realize that we can push companies, or we can push the EU, or we can push even probably not the US military, but Amazon. We can have effect on their thinking and on what they spend money on. Until that, it remains a problem that Intuitive or Amazon, they just don't want to spend more money on being more sustainable until people don't push them.
All right, thank you. Looking at Shirley, time-wise, we had the generous 5 minutes. Okay, perfect. No, that's all good. I just wanted, because I saw 5 minutes on the program, so I was wondering. Okay, perfect. So even better. I think one question that I also maybe personally like, but it's what is a misconception that people might have about robots in healthcare? What that you have encountered? What do you think is something that you feel like needs to still be worked on? Maybe it's an expectation, maybe it's a cliche. It's an open question, but maybe let's start with you, Kristóf, on this one. Could you maybe share your thoughts?
Well, the first thing is that I think it's the mistake of all of us that, for example, we call it robotic surgery, and we all know that it's not robots that do the surgery. Da Vinci robot is not even a robot in a technical way. It's just an electromechanical telemanipulation system or something like that. What's it exactly? Telemanipulator, yes. So it's not even a robot. We should at least call this whole topic robot-assisted surgery or robot-assisted minimally invasive surgery, but definitely not robotic surgery, because then a patient comes in and sees that, a guy sitting there. What is he doing there? I came here to be operated by a robot. So yes, if we should really start using clear phrases, and the same with AI that you mentioned previously. We cannot expect everyone to, even I don't understand most aspects of AI. So if we just say that this is AI enhanced manipulator or AI enhanced or embodied AI, we used to say this about robotics, that it's just embodied AI. There are many types of AI, so we just, in my opinion, need to be much more specific and need to have the right phrases for the right things.
Yeah, thank you. That's a very good one. Anne?
Yeah, the definition challenge always popping up. I also on robotics and the different fields, like if you go in a manufacturing field versus a healthcare field, then again another ISO robotic definition is there. So even where there is some standardization, we are still actually having this semantic challenges. The point I want to repeat, because I also put it in my presentation, is the and it's related, is the invisible work. So the expectation that everything will be smoother, easier, and that there will be no work with it for a human. Maybe not the same work that you were doing before, but you need to prepare to put it into use. You need to maintain it. You need to oversight it. So it's not a cut out, automate everything kind of solution, I think.
Thank you, Nicola.
So I think that we should always see this aspect of robotic surgery, if you want to call it in this way, as a tool to achieve a goal. Okay, so we can use technologies, the most important and advanced technologies tool in the field, but obviously behind there is always the hands of a surgeon, of doctors or nurses. I mean, it's always matter of be able to use a tool in the better way for the patient. I think that this is not always clear. I think that maybe it's true that the word robotic surgery can be a little bit confusing, can be a little bit not be straightforward for all the population of the patients. And under this point of view, it's obviously our duty to make aware patient population about what we mean with robotic surgery. Events like this one, conferences and all this kind of events obviously help to produce a good information about what we mean for robotic surgery. But yes, I totally agree about the fact that we should also in this case standardize a little bit better the words that we use.
Yeah, that's also a conversation that we had with Anne and Bram and many others when we worked on the SDG and robotics. The first question was definition, and I remember a few colleagues talking and explaining to a question that someone had about, okay, where does it stop, robotics? And someone said, oh, it can go up to satellites. And then it says, okay, that seems very broad and maybe a little not misleading, but it's a moving target, nearly impossible to grasp. So, okay, thank you for bringing that. One aspect that was, I think, briefly touched upon, but I think maybe not enough, was the importance of data as well. What happens with the data collected with all this if we can call it still robotic surgery processes. But maybe I wanted to hear you all, maybe starting with you, Nicola, on this. I think there are, of course, ethical challenges regarding what happens with all the data being collected, for instance, about patients, even maybe about professionals. And are there already questions that you are faced with in your organization about the use of data in the context of robotics in healthcare?
So first of all, robotics, robotic systems helped a lot in terms of data collection and the possibility to use this kind of data for scientific production and also technology improvement, like the integration of artificial intelligence in this kind of systems. So yes, it's a very important matter. It's a very important field, and robots in this situation help a lot. The data that were collected by within a robotic system or regarding a robotic system obviously are always property of the patients, and we never use the informations about patients without a consensus or an ethical approval behind. So this kind of situation didn't change, okay, luckily, because it's always very important to protect the privacy and the information about patient, even if we are using a tool that able us to have more easily access to this kind of informations. So yes, under one point of view, it's something that robots is something that help the collection of data and the improvement in the technologies application to medicine. But on the other hand, I think that there should be a growing attention also in the ethical approval for all these type of data that we use, the artificial intelligence use, big data analysis. But this is something that is happening actually, because there are even more and more regulamentalization for the application of this kind of new technologies in the scientific under a scientific point of view, under scientific production. So yes.
Thank you, Anne.
Yeah, for me, a robotic system is just like any other sensor that's providing data that can be informative about procedure, about context, about the conditions of the patient. And of course, we need to be aware that those data are collected with the primary use of providing medical acts. And so that's also why how they are optimized to measure and to support actually this kind of clinical intervention. And when we then start dreaming, of course, as researchers mainly, about reusing this data for secondary use, then there's popping up a lot of challenges about how do we organize that, because how do we get then this data out in a safe way from, for example, the hospital, or if we consider the data as property of the patient, how do we organize that it's still in an understandable way, and that people can clearly also assess the data quality and know also how they are reusing it, and how do you inform people about that? Because I think what we are organizing today in Europe, and that's then called the data spaces, and we're trying to figure out, we're in the process of how do we create a data governance in a proper way that's interesting for the public good from a research perspective or from a government perspective, but in a way not inhibit or imply other kind of human rights transgressions or something. So that's what we're trying to find out. How do we do it also in a feasible way? And we're making progress there, but we're not there yet.
Thank you. Kristóf?
Yes, so of course it's the question between the rights of individuals and the good for the society is really difficult in this case, as the previous speaker mentioned. But I have this exact question was asked at last year's Hamlin Symposium as well, but not from researchers, but actually from entrepreneurs and company CTOs. There was someone from Intuitive and Hugo and other bigger companies. And all of them agreed on stage that, of course, we need to collect the data and we need to collect it responsibly and we need to share it with the others because it would be the best for the whole society to share all our data, and then everyone can increase their performance and everyone can learn from the data of each other. And when the questioner asked that, okay, that from each of them, that what would be your first step, then the guy said, we are waiting for the data from Intuitive because, of course, they have the most data. And Intuitive said that, we have the most data. Why would we share it with everyone right now? Please provide us something, and then we can answer it with our data. And it just went on for like this for 10 minutes. And at the end, when they came up, one of the panelist speakers just was sitting in front of me, one row before me, one row in front of me, and he came up. There was his colleague sitting, and they started to laugh. Yeah, sure, we will naturally send our data for free. Yeah, this won't happen.
But that's a very interesting challenge that we saw in other technological fields, who belongs the innovation to, and in the context of, for instance, public missions like healthcare, in public settings like hospitals, if tools are belong to, or somewhat belong to also companies, the question of ownership of data, sharing of data becomes interestingly more complex. I think as one of the final questions, I wanted to maybe relay back to some of the things that Adjung said before and Franziska Kirstein also before, is that people do change their behaviors around robots or in the presence of a robot. And could you maybe share, in your view, what is one behavior or attitude that has changed among healthcare professionals that you have seen since the introduction or familiarization with robots in this context? Maybe let's start with you, Kristóf.
I have seen any kind of responses from obviously the older the surgeon is, the harder for him or her to get used to these new technologies, and that's natural. But I have seen from older surgeons as well, that they were like enthusiasts to, here is a real Da Vinci robot in your laboratory. We have quite really few Da Vincis in Hungary, so even surgeons don't get lucky usually enough to try one. And they were enthusiasts and asked us to turn it on and just let them try it. And they were looking around and asking questions. And on the other side, there was a visiting surgeon in our lab who just looked at the Da Vinci like this and said that a robot will never be as good as me, and just went on. But from the, as I mentioned in my presentation, the first Da Vincis in hospitals in Hungary appeared 2 years ago, and we are lucky enough to have common projects with some of the groups. And they love it. So they say one of them said, for example, his colleague said that he's one of the best laparoscopic surgeons in his field, and he said that I realized that I am so much worse yet with the Da Vinci robot than with my hands, but I can already see the potential. So he's using the robot. He knows that he's not that good yet, but he's training, because he feels that he can be. In 1 year, 2 years, he can be much better using the robot.
Thank you. And Anne, you've followed a lot of robotics innovation in hospitals, for instance, or healthcare. So maybe can you share your thoughts?
Yeah, I think what's the risk maybe there is the novelty effect of robots. They have it always, and the more humanoid characteristics, the more like we're like enchanted at first view. But that also goes with a rise in expectations about what they can perform, how much benefits we are expecting from that technology, how much we forget actually that it's a tool and that it's not perfect and that mistakes can be made. And yeah, so I'm a bit worried always, like if what happens after the novelty effect wears off, and I think we need also studies to understand that better. How does that work? And of course, from a marketing perspective, that's lovely because you can sell your product and then you cashed. But from a healthcare perspective, like how can you integrate it really beyond that novelty and also include everybody in the system and creating the most benefit you can get with it.
Thank you, Nicola.
So for a surgeon point of view, there are two different generations. There is the new generation, like my generation, or also the years a little bit older than me, that are very obviously, I mean, we grow with the in a robotic era of surgery, so we are used, for us is normal to have robots in our OR and to use robots to perform surgery. For the old generation is not always true. Okay, indeed, one of the main obstacles of the diffusion of the robotic system in countries and hospitals which can afford the cost of a robotic system sometimes, and not, I mean, pretty often, is the resistance of the old surgeons that they don't want to learn another technique because they say, okay, I spent all my life doing what I'm doing, why I should change for something that actually I don't know if I will reach the same performance. So yeah, for sure, the old generation will be, but I think just for a couple of years more, an obstacle to the diffusion of robotic surgery everywhere. But yeah, the new generation, this is not a problem for new generations. Patients, so obviously I can talk about my patients, my specialty, and they want robotic surgery. Patient came to you asking for robotic surgery, okay? Because for some kinds of surgeries, like radical prostatectomy, now is the gold standard, okay? So people know the advantages of robotic surgery and they ask for robotic surgery. If you have patients that came to you and ask for this kind of operation, this kind of surgeries, and you say to them that you can't use robots because in your hospital it's not allowed or it's not present, they change the doctors, I mean, they change surgeons, and this is true, it's a reality, it's a matter of fact. So yeah, I think that patients are already aware about the possibility to be operated by using a robotic platform, and also the information, the media, the information at this point of view are pushing a lot. So yeah, patients want robotic surgery.
That's a very interesting way to finish also this conversation. Been told it's over. So a round of applause, please. Thank you all for being present. And now it's time for sandwiches. So thank you.
Okay, welcome back everybody to the second part in the afternoon of our today's forum. I have the joy to introduce first Shirley. She is a co-worker of mine. I'm very happy about that. And she graduated or did her PhD at the VUB at SMIT and has a very long, I think over 10 years of experience in the field of human-robot interaction and collaboration. And she will now give a little intro on the BrIAS. And then we have Marta and then Shirley again with her presentation. Thanks.
Thank you, Michelle, for the short introduction. Well, everyone, welcome. In the morning, we had a session on sustainable robotics in healthcare and in the surgical domain. And this afternoon, we will be focusing more on the domain of manufacturing or production. It's a domain that Professor Anja and me have been already done research in since, well, more than 10 years together. But first, I wanted to give a bit of context because there are a lot of people who are, let's say, affiliated also with the BrIAS program, but there are also some people who are maybe don't know what BrIAS is, so I will give a short introduction. So the BrIAS Institute is the Brussels Institute for Advanced Studies, and it's a collaboration between the ULB and the VUB. And what they do is they try to bring together people with a lot of knowledge from academia as well as outside academia. And actually this forum is part of that program. So in this year the theme is sustainable robotics, so it's very, not coincidentally, related to the theme today. So between January and May this year, a lot of people who are already further in their research, they came to Brussels to connect with other people here and also with the other people visiting. And that is why since the beginning of this year we have organized weekly seminars, and then we also organize 4 big events including this one. So to give that a bit of context. So the idea is to bring all these people together to Brussels and have them interact and give an opportunity for more collaborations and maybe also make connections with researchers from other fields or from your own field that maybe you didn't know yet. And I must say it's very effective. I've met already so many people this year, so I can really personally attest to that. It's very nice to be part of this program. I will give back the word to Michelle then.
Yeah, thanks, Shirley. So now will be next up will be Marta Lorenzini. You can already see the slide here. She's from the Italian Institute of Technology, and her background is electronics, information, and bioengineering. And she has been engaging into a lot of projects, among them a EU Horizon project called Sophia, and I think she will bring a few of experiences from that into her presentation, and I'm very happy to listen to it now. Thanks.
So first of all, thank you very much, Michelle and Shirley, for the presentation. Can you hear me? Yes. Okay. So I am Marta Lorenzini, and I'm a postdoc researcher at the Human Robot Interfaces and Interaction Lab at the Italian Institute of Technology, which is a research institute in Genova, Italy. Today, I will give this presentation about the importance of sustainability goals in the production domain and how we can achieve them via human-robot collaboration. So this is a picture of my lab, which is a pretty young and international group. The principal investigator of my research line is Dr. Arash Judani, here on the right. And apart from the lab, we have a couple of joint labs, one with Chilometro Rosso, which is a consortium of company in Bergamo, Italy, and another one with Leonardo. These are some of the projects that are funding our research. We have a couple of ERC, 3 projects within the Horizon 2020 program, among which we have the Sophia project, and we are collaborating in it with VUB. And also we have some national project with the National Institute for Health and Safety in Italy and some collaboration with companies. So why do we need collaborative robot in the industry? First of all, given the mass customization requirement of the market nowadays, many companies are forced to make their production line more flexible. But since they, in most of the cases, they cannot achieve this level of flexibility, they have to go for outsourcing, which have several potential issues, from quality control to data security and compliance risks, but also hidden costs and delays. Then we have the issue related to the health of the worker. So the excessive, both physical and cognitive load associated with the worker's activity may induce the so-called musculoskeletal disorders, but also mental illnesses. And these two cost to the European Union, respectively 240 and 617 billion euros every year due to lost productivity and absence due to sickness. And finally, we have the workforce that is getting every year older and older. And we expect a labor gap around 8 million of workers by 2030. In our lab, in our research line, we believe that the solution to all these issues can be given by collaborative robots. So the idea is basically to create this synergy between human and robot, in which the human put the problem-solving capability, the flexibility, the intelligence, and the robot put the endurance, the precision, and power. And by using this synergy, it is possible to create a production line which are more flexible, to make the workplace more inclusive, but also to increase the safety and health of the workers. And this can be done mostly in the context of small and medium enterprises, where full automation is not a possibility. Today, I will go more into the detail of how can cobots contribute to sustainability. And we found, let's say, three main goals that are somehow related to the Sustainability Development Goals 9, 3, and 12, the SDG 9, 3, and 12. But, I mean, while I was doing the presentation, I was actually realizing that we go also beyond this objective, even if they are the most closely related, let's say. So the first objective would be resource efficiency through semi-automation. So by semi-automation, we mean this collaboration between human and robot. Robots are energy saving by design, and they have the potential to minimize the errors, to have a precise and accurate control of the production line, and also to optimize the logistics. But in order to implement this semi-automation, so this collaboration between human and robots, we need the robot to be flexible, mostly to adapt to the requirement of small and medium enterprises. So how? Now I will show you some example of how this robot can be made flexible. Here we have a simple task, which is box filling. The first step here is to basically observe how the human is doing the task, and then we try to reproduce the same thing with the robot. So here the robot is initially basically filling the box, and thanks to a camera, it can create an occupancy grid according to which it can understand where to put the piece. But then there may be another human that go into the scene and put other pieces. So the robot needs to replan basically its trajectory according to the new occupancy grid, and need to adapt its behavior according to basically the environmental changes. And also when there are some changements in the conditions, for example, the box can be tilted, something can happen, the robot again needs to adapt to the environmental changes, and this can be done thanks to the camera and this layer of intelligence on the top of the robot. And this is the, let's say, level of flexibility that we would like to have from our human-robot collaboration system. Another application that we develop in this direction is the one that we called Mokaman. So we mostly work with this type of robot, which are mobile manipulators. Basically, we put together a mobile base and a robotic manipulator with an end effector. And we develop, we call this robot MOCA, which stands for Mobile Collaborative Robot Assistant. And we developed this system, which we called Mokaman, that is basically a handle, an interface toward which the person can easily move the robot. So as you can see in this video, basically the operator can move the robot without any effort, because thanks to the whole body controller of the robot, it is possible for the robot to feel the interaction forces at the handle and move with respect to the intention of the person. And this kind of task can be done. So for example, if the operator needs to move weight around even 10 kilos, depending on the payload of the robot, it is possible to do it without feeling any effort, any physical effort for the operator. Another example are overhead activities, which are the most dangerous for the shoulder joint and are the one that very often develop musculoskeletal disorder. Also in this case, the robot can support the weight of the tool, and the person just need to do the, let's say, intelligent part of the task, which is basically to guide the robot toward the point in which you have to do the task, which is in this case drilling. Then with this interface, another thing that can be done is to teach to the robot how to do a task. This is quite important in small and medium enterprises because you need to change the task very often. So you need to give to the operator a way to make the robot learn different tasks in an easy way. With this system, it is possible to teach the task to the robot without programming it. It's an easy interface that anyone, even without let's say PhD in robotics, can do. And once the robot has learned the task, it is possible for it to reproduce the same thing with the same position and the same forces. Also, since the robot has learned the task in terms of position and forces, if you give priority to the forces, the robot can reproduce the task even if there are some perturbation from the outside. Of course, in general, this shouldn't happen in a real factory, but it was only to show the potential of the application. And for last, this application show how we can also do task allocation. So let's say that you have to do the filling of a pallet. There are some boxes that can be placed by the robot because they may be more dangerous, they have some dangerous stuff inside or heavier. Then the light box can be taken by the human. And these tasks are allocated thanks to an interface which is telling to the human which are the tasks for the human, which are the tasks for the robot, but also which are the tasks that need to be done in collaboration. Because let's say that you have a bulky object or something that cannot be done by neither the human or the robot alone, so they can do it together in human-robot collaboration. And also, since the filling of the pallet is optimized, it is possible to do it in the most efficient and time-saving way. Let's go now to the second goal toward which we want to use robotics, collaborative robots, which is connected somehow to SDG 3. So since it's very important to preserve the human capital and improve the health and safety of the workers, one of the topics on which we work most is basically the improvement of the safety. And the first step here is to monitor the human. So there are several ways to monitor the human, but most of the sensors that are currently available are sensors that you need to put on the body, and they may be annoying for workers. So in our lab, we are developing a system which is called RealMove, and is basically a multi-camera system. We have 4 simple RGB cameras, and with this camera, with some skeletal tracking on the top, it is possible to reconstruct the 3D position of the person in a very accurate way, also compared to the system which are available in the market. Actually, this tool called RealMove, it's also something that my colleague want to make a startup, so we hope to achieve also this objective. Once we have this information about the movement of the human, what we want to do with robots is to mitigate the load. And we can start with the mitigation of the physical load. So in order to mitigate the physical load, we have, of course, first to estimate it. In this study, we basically test this system in order to have a subject-specific model of the center of pressure of the person. Subject-specific because, of course, different people has different body characteristics, inertial properties, and so on. So we want to work with a subject-specific model. Once the model has been estimated with this calibration procedure, we can obtain what we call the overloading joint torque, which are basically the torque that are given by an external load on the human main joint. And we obtain this torque with the difference between the model of the center of pressure and the measure one, which here is obtained with a force plate, but can be obtained also, for example, with sensor insoles in the shoes. And thanks to this estimation, we can obtain this overload engine torque, which is basically a rough estimation of the load on the main joint. Once we have this information, we can use it in human-robot collaboration. So let's say that an operator is working with a robot in a position which is not ergonomic, as you can see from the interface, in which red, of course, means high and dangerous. The robot can then guide the person and make him assume a position which is more ergonomic because minimize this overload engine torque. And also the system is intelligent, so thanks to the camera, the robot can understand if the person is changing the hands or moving in the environment, and so it's possible for the robot to adapt to the requirement of the person. Then, apart from physical load, we have cognitive load that, as I was saying before, is as important as the physical load because it has the same impact on the society, or even a higher impact on the society. And thanks to the camera-based system that I showed you before, we are trying to find, let's say, a way to mitigate the cognitive load. The current system to detect the cognitive load are based on sensor that the person again need to wear. So basically EEG helmet or heart rate variability or the galvanic skin response. These are all signals that are a measure of the cognitive load, but needs a sensor that may be annoying for the worker. So what we investigate is the possibility to see the cognitive load understand the cognitive load of the person directly from the behavior of the person, which is captured through the camera. So looking at the attention of the person, so if the person is looking at the task, is looking at the instruction, or also if she's doing some self-touching movement or hyperactivity, all these body sign can tell us something about which is the cognitive load of the person. And thanks to the camera, we can have a rough estimation of this cognitive load. Once we have this information, similarly as we have done with the physical load, we can adapt the robot behavior based on the cognitive load. So for example, when the person is at rest, is quiet, the robot can push on the productivity, so use fast trajectories, go closer to the human in order to achieve the objective of the industry, which are reduced cycle time and more efficiency. But when the person is stressed, for example, because the task is too high or for other reason, the robot can then adapt to the state of the person and start adapting the interaction pace, going slower, a bit farther from the human, in order to give time to the human to reduce basically the cognitive load. The last objective which we want to talk is waste reduction through multi-purpose robots and how we want to achieve this objective. Basically, the platform that I showed you before, this MOCA, is not one robot for one single task, but we can use this robot for several tasks. And this is how we can, let's say, reduce the waste. The first thing in this direction is to make this robot safe. So what we have done is also to create a kind of skin around the robot which is made of capacitive sensor in order to make the person interact with the robot in a safe way. So here, basically, by feeling the forces, the robot can adapt to the changes, and also when the robot is going toward the human, it can basically avoid the person because it has this, let's say, safety countermeasure. With this safe robot, we can do basically different tasks, different applications. One of these applications is, for example, the transportation of heavy objects. So let's say that the payload of the robotic arm is not enough to take some object. For example, this object is 12 kilos. We can use the skin of the robot in order to move the object. And also if there are perturbations, as the one that my colleague Idil is creating on the object, we can basically keep this contact point and bring the object to the target through the admittance controller, which is based on the interaction forces that are felt by this robot skin that I was mentioned before. And also, if you go a bit further in the video, this can be done also with more bulky object, for example. So imagine that you need to bring around something like this. It can be done directly by the robot. In general, the idea is that all the tasks that shouldn't be done by the person because they are too dangerous or too heavy should be done by the robotic collaborator. And then there are also several other applications. So if you think about logistics, I don't know if you ever tried to move a pallet jack, but it's not intuitive at all. And this kind of tasks should be done by the robot, because if you program the robot in advance to first find the handle thanks to a vision system and then direct the pallet jack, this can be done easily by the robot. But also in terms of co-carrying, for example, when there are objects that are too bulky or too heavy to be transported by one person or by several persons, this can be done through human-robot collaboration. Finally, I would like to present you this last application that we developed with Mocha. That is, let's say, real waste reduction by doing garbage sorting through the platform. So thanks to a camera and a vision system, it is possible to detect the type of garbage which is in front of the robot and recognize basically if it's glass, plastic, metal, or other type of garbage, and then the robot can pick it up the object and put it into a box, let's say, on the back of the robot in order to do garbage sorting. And think about, I don't know, it can be something that is done in a company, but think about, I don't know, festival or big events. If you have robots like this one that can go around and take the garbage, this is something that usually the men are not happy to do, but again, this can be done by the robot. And this is the last application that I wanted to show you. So this is the end of my presentation. I would like to thank you for the attention, and if you have any question or curiosity, I would be available to answer.
Thanks a lot, Marta, for your nice presentation. Now for questions. Are there any questions in the audience?
Thank you for the nice presentation. I do have two questions, if I may. First one, you were specifically mentioning the SMEs in the beginning. We also work a lot with SMEs, and we see already by Industry 4.0, they're kind of overwhelmed when it comes to infrastructure, when it comes to education of the employees. Do you see an acceptance for the collaborative human robots with SMEs you're working with?
I didn't get very well. So sorry, I didn't get very well the.
So, sorry, I said we see a lot with the SMEs that they are hesitating to even adapt Industry 4.0. Because they don't have the infrastructure, they don't have the employees being trained on it. Do you see with the SMEs you're working with, do you see a good acceptance of the robot in the workforce?
Okay. So in our lab we work we work in a quite low TRL. So we test most of our technology in the research lab. So we have limited experience with real companies, but we had some of them, for example, within the SUPIA project in which we are collaborating with Shirley as well. And it's not easy actually, because as we were saying before with the surgeons, most of the workers think I can do better with the robot, I can even do without the robot. But I would say that most of the people are quite open to technology, so they're not completely against it by default, but they are interested in understand what can be done by technology. And of course, in general, if you are telling them, okay, there may be a tool that do the physical effort instead of you, they're quite happy about knowing which kind of tool it is. In terms of acceptability, there's still a lot of work to do, because the main issue is that they want something that make their life easier, but they also want it to be easy to use, let's say. And so the biggest challenge, I think, is to make this system usable. And this is why we are trying to work a lot on these interfaces as the one that I show, in which it's easy to teach to the robot what to do, or it's easy to interact with the robot. But in terms of reaction of the worker, let's say, we still have limited, let's say, experience, but I hope that in few years we will have more and I will be able to give a better answer.
Thank you. It's a perfect trajectory to my second question, because you also showed the video-based estimation of the stress level of the workers, and then it's a very sensitive topic, I would say. If you think about working somewhere and you're permanently, tracked by a video camera plus estimating your stress level. Also here, would you say that this is okay when it comes to workers' rights, when it comes to privacy, GDPR, all of this?
So, of course, this is a big issue that shouldn't be overestimated. But even if I was showing a video of a person doing a task, what we actually collect is the skeleton of the person. So basically, this kind of, maybe I can show it to you. These kind of points on the face of the person and the skeleton of the person. Sorry. What we actually collect are these points that we detect from the face of the person, but we can avoid to record the image of the person with all the biometric information and so on, which can be, of course, an issue in terms of privacy. So by only detecting this aggregate information out of the image, there shouldn't be many issues. Of course, it's something you have to deal with, because when you propose this kind of tool to a company, also now that we have the AI Act that is putting a lot of, let's say, limitation to what we can do with artificial intelligence, it's something that we need to put a lot of intention on. But what we are trying to do, again, is to not to collect the full image of the person with all the biometric information, but just a few important points or information that are not associated with the person itself or with the activities and performance of the person.
Okay, thanks. Any more? Yeah, I see someone in the back.
Thank you for the presentation. I'm actually, my question is on this slide as well. When it comes to cognitive load, and you're kind of talking about stress level and mental effort as well, if you're doing cognitive load, to me, it has some things to do with the level of focus of this person. That's not necessarily about stress per se, stress in a negative sense. Whereas if you were to put somebody in a very cognitively challenging situation where you have to multitask all the time or switch between tasks, I would say that's probably a higher cognitive load, because you have to focus so much rather than experiencing this kind of flow and enjoyable flow in terms of a cognitive load. So I wonder if you can speak a little bit more as to the binary axis or two axes in which you're measuring cognitive load, and whether you are looking at this kind of positive or negative aspect of the quantitative measures you're getting out of these predictors.
Yeah, okay, thank you for the question. I was not that precise with this work, actually I was going pretty fast, but basically what we have done here is to create a multi-factor system which try to catch what we call the cognitive load from let's say, the image of the person. I call it cognitive load because we search a bit into the cognitive science, even if we are not expert, and we found out that cognitive load is just the amount of cognitive processing that you are doing during a task. But then we tried we divide this cognitive load into two different factors. One is mental effort, which is more related to the task itself. So we try to what we use for computing mental effort is the attention that you put on the task. But consider that here the person was following some instructions, so also the time, how many switches you do along the instruction, how many switches you do between your task and instruction. we try to relate all the information that are related to the specific task to the mental demand required for that task. Then we found another aspect, we consider another aspect that we call stress level, that was more related to the behavior of the person. So this hyperactivity movement and this self-touching movement were associated to stress, which can be positive or negative, I agree with you. But in general, what we have done is basically to first measure a kind of baseline. So there are some people that are doing self-touching and they are hyperactive by default, even if they are not stressed, and some other people that are quiet, and when they start moving fast, it means that they are stressed. So we computed the stress level with respect to this baseline, and we related only to the behavior of the person without connecting it to the task. And the way that we basically validate these two measurements is to correlate them to some physiological measure. So we correlate mental effort to the heart rate variability, in particular to the ratio between low frequency and high frequency, and we relate the stress level to the galvanic skin response, because we found in literature that are correlated. And this is how we, let's say, analyze cognitive load in a more detailed way. But if you are interested in other details, I can also refer you to the papers. We did several works on this topic. So,
thank you.
You're welcome.
Okay, any more? Do we have some in the World Wide Web? No? Okay. Maybe one I had in my mind, more on the environmental dimension. You said at the beginning, I think it was one of the first slides, where you said that robots or automation is by design more efficient. You could always argue that no robot is probably more efficient in terms of energy consumption than one robot. So did you put up any measures or metrics for actually trying to look into that a bit more, like see how efficient or more efficient or maybe less efficient the use of a robot is in terms of environmental sustainability?
We didn't investigate that aspect that much, because I mean what we do is to try to, let's say, create these prototypes about possible tools that have to be used in the industry. Then I would say that this kind of study should be done in a later stage. So you have the technology, you try to apply it in a company, and you try to optimize the energy reduction. You try to optimize it more on the sustainability. At the moment, we don't do this kind of investigation, but the idea is that once we try to put this solution in real industry, this will be done, of course.
Thanks. I think then we can conclude. Thank you very much again. Give a round of applause to Marta. Thanks. So next up, I think I don't need to introduce you again, Shirley. You have everything ready on the computer? Yes, I think. Okay. Yes, I'll leave you to it.
Oh, it went by itself, or press some button? I hope my slides will not move by themselves. Good afternoon again. Well, Michel already introduced me. So while I was practicing, I was introducing myself, but it's not needed anymore. I'm a postdoc at SMIT at the Vrije Universiteit Brussels, and also associated with the FARI Institute. And for more than 10 years, I've now been working with Professor Anja, and we have a team that focuses on research on digital health and work. We're with 7-8 people in total, and I don't know if I already said this before, because in these years we have been working on both the topics of the morning, robots in healthcare and other technologies used in healthcare, but also on robots in production. And I want to share a bit more on one of the projects we did there. So in our team, we are focusing on these 4 teams on the implementation of digital healthcare innovations and people-centered care. So examples of this is, for instance, the use of technology in the operating room, for instance, using a HoloLens to help with neurosurgery, or using devices for self-management, for caring, for people to live more independently. And what I forgot to say is that we're all social scientists in our research group, and we study it from the human aspect, let's say. We also focus on human AI and human-robot interaction and independency. For me, that includes robots, social robots, industrial robots, but also exoskeletons, because in a way they are becoming more and more like a robot. We also focus on trustworthiness of human-centered AI. This is being critical about if you train an algorithm, where does the data come from? What does the data look like? But also more from the side of, okay, if we want to use a robot in a nursing home, how should that robot behave? Can we make an algorithm together with the people working there to see that the robot does actually what they would like to do? Another topic is also AI governance. So yeah, here is this picture again. I think we have seen it a lot. When I was preparing for this presentation, I was talking to Anja, you know, I still don't really feel comfortable talking about sustainability, but actually sustainability was always in our research, but maybe not like, let's say, the energy saving consume, more like good for the planet type of sustainability, but social sustainability is, I think, at the core of the research that we do. We try to make technologies so people can age for the people's well-being, both at work, but also in a healthcare context. Since 2015, we have been doing research on collaborative robots. This is the Baxter robot. He's retired now. He's in the lobby now in the building. And this was, for me, my first experience with collaborative robots. We did a project together with Audi Brussels. We talked to the employees, because at the time in 2015, there were not so many collaborative robots already implemented in factories. And actually, during this project, the first collaborative robot was implemented in that factory. And what we tried to do is we talked to the people working there. We talked about them, what are you concerned about? And in the end, this project resulted in a very nice actual implementation of a collaborative robot. I don't have enough time to say more, but I will go more to another project we're working on now. The EAO Sophia project, and that's also how I met Marta. This European project led by IIT. IIT started in 2019, and the focus of the this project was to make technologies, both wearbots and cobots. And the idea is that you can use different components and combine them together to make the thing that you need in a production setting. So in this project, we work together with 3 companies. We work with a SME, about 50 people. We worked with Volkswagen in Germany, and we work with Hydria in Slovenia. And in this talk, I want to share a bit about the co-creation process we went through them and how we involved people to make a technology solution that was actually acceptable by the workers there. So the company that we collaborate very closely with is Hankam Gears. Hankam Gears is a company in the Netherlands, and what they make is gears. And first what we wanted to do was we wanted to find out what do the people actually need. And we did it via interactive sessions, including co-creation sessions. And in the end, the colleagues of mine from the robotics department, led by Professor Bram van der Borg, they created an implementation. And all the work that I'm telling you now about today is done in collaboration with their department. We have been, very, I think, lucky, and I really enjoy working with them. We've been working already with them since 2015. So this work is now under review. It's also the work of Long, Konstantin, and Ilias. So this shows in one maybe a bit busy picture, but I will walk you through the steps. So what we try to do is we did a series of co-creation workshops. where we first try to identify what are the needs. Then we try to identify it. Then we wanted to co-create with them which solutions they would like, and then we actually proposed a solution and showed it to them. So the context of this project, as I told you, it started in 2019. So we were very lucky to have a project consortium meeting in Italy in the beginning of 2019, and everyone knows what happened next is COVID hit Europe as well. And then we had to start working online. So these co-creation workshops were done online. And what we actually typically do in our research is we try to go to the context where technology is being used, whether it's a robot, exoskeleton, social robot, or whatever technology is, we go there first and we look what the people do and what kind of context they work at. In this case, that was not directly the problem due to various travel restrictions between the Netherlands and Belgium. So we improvised and sort of learned by doing an online workshop. I think for myself, it was the first online co-creation workshop that I did. We used the relay method. So basically, I designed these different sheets. It's in Dutch, but basically, I give them some exercises to think about. We did this work with several participants. They were all male, and they were working at Hancom Robotics. And I divided them in 3 groups. I think in the first session there were like 3 or 4 people, so there were 3 groups in total, and one was joining, well, was more listening in. Where I first asked them, okay, please create, if you have a collaborative robot, think about where would you like to use it in your place of work. Then they had to write down those ideas or draw them, whatever they felt comfortable with. And after that, they had to take that idea, give it to the person next to them, and then the other person had to add to that or improve it. Then there was another round where the third person in line, or the third group in line, changed something about it, and then they came to several use cases. So this is an example of the use cases they came up with. So first on the left you see a gear. On the right they write down, oh, the robot will be your personal assistant, for instance, for fetching coffee. But after we put all the ideas together, they did agree that they wanted to use a robot for deburring. So then there was a bit of a challenge of context, because I had no idea what deburring was at the moment. So I had to look up some videos, and because we were not able to do that, so we had a lot of extra communication, let's say, and also just, gaining more knowledge on the topic to see what this is. So basically, gears, when they are made, they can have very sharp edges, as you can see here. And what they do now is they manually file them off. So in the second workshop, what we did is we showed several ideas of how they could interact with the robot, and we challenged them to actually role-play this robot scenario. So what happened is one person played the robot, one person played the operator, and one person, and then we discussed first how it should work. You can also see some paper on the table. So they also said, okay, there should be a button. So they drew it, and then they role-played this whole scene. We proposed different options. For instance, the robot could go to a particular height. And one of the things we also learned is that when they want to collaborate with the robot and do the deburring, so the robot should hold the gear, and then the person should file, but the robot should also give it at an ergonomic height to the person that's standing there. So the topic of people tracking and cameras and sensors also came up. We asked, okay, what do you want? Because there are several systems out there, things that you can put on your body or cameras. But they were really clear they don't want like extra sensors on their body, because in their work of context they would just lose it or it would break down. So they were like, okay, for this need for doing it in an ergonomic height, they were fine with having some sort of camera or system that could do that and could adapt it to how they worked. They also started that they wanted to sort of position the gear how they wanted it by touching the robot. You have this mode on the robot, you touch the robot and then you can move it in all directions. That's what they also wanted. But the operators also wanted to be in control of the way the gear rotated. So you can rotate in 2 directions and they wanted to choose that. Another thing they were also that they were interested in is getting feedback on when they put too much pressure on the gear. So what you can do is you can file, but they put their whole body into it sometimes, and they wanted some feedback if the pressure was too high. So after we did this role-playing exercise, we wanted to ask more feedback on how it should, whether what we made was according to what they liked. And I will show you now what you made. So before, we did not really know what the order was and how the robot should work, but there were steps there that we found out in the last workshop. So first, the robot has to give it at the right height, then you start deburring, then you define the rotation of the, how the robot is turning the gear. And this is a video which I didn't test yet, so I hope it works. This was made by colleagues from the robotics department. So this is the process. You can see how it could be. So the robot arrives. It's rotating in a certain direction. And then they get some feedback if their body is not in an ergonomic posture. The video continues a bit, but I'll leave it for that. And so we in the final interview, we showed it to them and we asked their feedback. And I think one of the most striking feedback from them to me was that they actually already want it in there at work tomorrow. Like they already wanted it to work. They really see a lot of potential in using it. Of course, the implementation as it was made now was not finished yet, but the idea, that's what they like. So I wrote down some reflection on this whole trajectory. So what we try to do often in a type of research we do where we want to invite people to give their opinion, future users. And I think I like that you came with a question about the SMEs, because I think that was one of the challenging and yet challenging thing in this project is it was a small company. So if we wanted to take workers from them, and involve them in the research, it also meant that they couldn't do production at the same time. So we had some practical challenges. So that we had to be flexible. That we last minute the workshop was cancelled because there were too many people sick, or it was the holiday season. So I think if you do this kind of research and you want to involve people, you have to be very flexible. But I think a good thing that we did in this project is that we actually involved already the stakeholders in the project, and it should sort of be obligatory, but ideally, if you want to involve any end users, it would be already in the project and not when the project is already finished. So running an online co-creation session was for me quite challenging. We made it work, but it's like there is this power imbalance because you as a researcher are on one side, and then the employees they were on the other side, and they were with. Depending on the workshop, they were with 2, 3, 4 people, and then also our contact person there. So it was sometimes hard to steer the conversation a bit, but I think in the end we managed. Due to COVID, and because we couldn't do a lot of visits in the beginning, we lacked some context, so we needed some clarifications and ask more questions after, because sometimes in the workshop they were talking about a specific process or about the pedals, and we were not really sure what they meant because we hadn't visited yet. So we try to compensate that with asking extra videos and extra images. For instance, what is deburring? How do they now? So what I would like to take away from this is that If you're doing this kind of research co-creation, you have to prepare. So every time I prepared a workshop with a format, but in the end, sometimes I had to improvise a bit or change part of the script because there were not enough people or the workshop was cancelled, or so you have to be very flexible. Despite these challenges, I think it's very important to keep involving end users in research. And don't forget the importance of context. I really missed context in this project, and in a future project I would definitely, I would assume there will not be another COVID outbreak, but to visit these companies or these contexts as soon as possible. Thank you for your attention.
Thank you very much, Shirley. I definitely liked the idea of the role play. I think that's the best version of like how to want your robot or how to want to act your robot in your facilities.
It also really made, I forgot to say that, but it makes assumptions explicit. Like it's the way someone holds the wheel, and you can see like where do they hold the gear. It's not they're holding it here. It's really depending on the person, they hold it in a certain position.
Thanks. And we'll just jump into the questions. There's one in the back.
Thank you, Shirley. You have lots of experience, so it was great to see different projects. I was wondering about the evaluations that you use at the end of these small or big projects, because there are different parties, stakeholders involved, and they have different expectations. Of course, you cannot control the outbreak of a disease that's beyond everybody's control or power. But I was wondering, how do you measure what do you measure? Those are two questions, actually. What exactly do you want to measure, and how do you measure?
So what we usually do in our research is use technology acceptance models. So, for instance, for occupational exoskeletons, I've developed a framework that summarizes which aspects are important for acceptance, and then measuring all these different factors plus the intention to use. So I don't know if you're familiar with technology acceptance. So that's what we typically do. So survey questions, but we also try to do qualitative interviews where possible, and we like to combine it. I think in the context of the Sophia project, we try to focus on people that would actually be using that technology. So in the HANCAM case, there was maybe max 5 people. And as you might know, technology acceptance models, they usually use SEM modeling, and you really need like more than 200 people. That was not even possible, but so we do measure it with questions, we do with interviews, but and then we've also developed in previous projects also questionnaires based on acceptance, but then with collaborative robots.
Right. So you answered part of my question, because I was curious about the generalizability. Because if you have a very small sample, then it is perhaps helpful for that small community, but for a more general public, perhaps it leaves some questions open. I don't have a solution myself, but I was just wondering how you're thinking about it. So thank you.
I find that a confronting question, but it's because as a qualitative researcher trying to publish in a domain that's more technical, people are always asking for generalization and numbers. So even though we know we cannot do SEM modeling on these 5 people who filled in the questionnaire, we do it because engineers who are often other authors in the journals we're submitting to, they want numbers. And I see Anne, because I know Anne also quite well, and we were working a lot, that she also wants to add to this comment or not. Yes.
For me, if you're talking about innovation, the exploration and enabling people to have a voice in the process is for me the more important than trying to evaluate and generalize to a broad public at that moment in time. For me, that's something you do later in the implementation strategy to check and see how your intervention maybe to need some changes to make it more better fit in the context. I think don't underestimate case-by-case comparison of those small communities, and that's also where I think the value of very interpretive research, where the complexity is not reduced of the context, can give very valuable information for design, because you are trying to inform change in the future, which is a different purpose than trying to check like how things are done now. So I think it's also in the purpose which make the type of evaluation different.
Is there any more questions from the audience or from the work? Okay. Maybe I can add one myself. I really like the notion, I think what Anja said, of this more user-oriented and more in terms of the market, I would say pull, trying to use the pull factors, like what do the users need, what do they want, and not coming up with an idea and trying to like push it onto the market, but have this pull. And in my project, we kind of tried to do it, but we were already too late. We had an idea that we wanted to implement, and then we introduced the users or the workers that were supposed to work with the robot into the whole development procedure, but I think already a bit too late. But we still had a lot of like very positive comments on the acceptance, that they were like really happy that we involved them actually and like voiced that in every workshop. Did you have the same experience that the people were like really thankful, or being just like in the picture and not being left out?
Yeah, they liked participating in the workshops, and I think what was most striking that they were so positive about the end implementation. I mean, yes, we asked them what they want, but yeah, to some extent, as a person, I was a bit surprised that they were really happy and that they actually wanted it tomorrow already. Of course, sometimes you already have to make some decisions. So as you might see in my template, I'll just quickly go back. We already know that we would do something with a collaborative robot, like using Baxter or using a social robot in this context was already outside of scope. So we already did scope it a bit, but still with a collaborative robot there are still many possibilities. Yeah.
Thanks. One more question.
I just have a follow-up on that. Have you really made people who have no experience with robotic systems to play with them once it is developed? So just putting them in a room with the robot, and once you have developed the use case, did you do some studies with people who are not into robotics? And was there any feedback from that kind of studies?
I don't fully understand. So you're
people who have no experience in robotics.
Yeah.
Have you ever done tests with them?
I'm thinking. So, for instance, in the Audi case, they all knew what the industrial robot was because they had been working with industrial robots in the factory. There were more than 500 different industrial robots there. There was no cobot yet, and they were very concerned about how the cobot could take their job. Still, even though they know these industrial robots already existed. At the same time, then when they sell Baxter, they said like, yeah, I can do it myself and I can do it faster. So I don't know if I've ever really had people with no robotic experience, because I think at the time the SME didn't have cobots yet, but during their project they also had a universal robot, but I would have to look it up when in this process it was introduced. So it's. I forgot. Probably not, because it was quite early. But
Okay. Yeah,
I hope that answers your question a bit. But we typically see that regardless of what people already know, they often have high expectations of robots, and then when they actually see them. And that's why it's very important, I think, to bring people in contact with the technology so they can see what it can do and what it also cannot do.
Okay. One more question, one last question. We are out of time.
Thank you. I just realized that you just mentioned, and I saw on the video as well, that when we are using collaborative robots, they are just slow by design because they have to be slow.
Yes.
Doesn't it irritate the workers, or maybe not the workers, but people in higher places in these companies? So doesn't it ruin productivity, or what can be a solution here?
It's a good question. I'm thinking out loud. So, and I see that Bram also wants to respond. Maybe Michel can walk towards Bram while I give my vision on that. Back in 2016, 17, we went to Audi in Germany, and we saw that some of these collaborative robots, who could in theory work together with people, they were caged, so they could work faster. So, I think there are already ongoing a lot of different developments ongoing where the robots are sensitive about people present, and that they can speed up when people are not close and when they are, in a safe zone, and then the robots can work faster. So I think there is some. I don't think that is the main issue for the adoption at the moment, but I will maybe now refer the word to Bram because he's a roboticist.
I think it's a serious issue that it's just too slow. Because companies do a certain investment and it costs an amount of money, and the speed of the robots is so slow that the return on investment crashes. But I think also, Shirley, I thought during your research, it also showed that the robot is working slow and that annoys the human. So it's also, I think, bad from a social acceptance. But the reason why they're slow is from a safety standard, that this imposes it. And then there are solutions to make it faster, which are safety mats and cameras and a lot of technologies. But often they need to be installed separately. And so the certification, the robot is certified, but the system is not certified. And so that means if you add an end effector tool, like a screwdriver or a safety mat or a camera, you need to certify it again, and that adds up to the costs. And so that's why we're developing, and that's in the AI Experience Center, that SafeBot, a new onboard safety proximity system that can, independent of the environmental conditions, like smoke or rain or no light, can guarantee that it can detect humans, but this is a huge challenge. Because, you always need to guarantee that if nobody's there, you can move fast, and when someone enters, and whatever that person does, you need to be guaranteed that you can detect that person. And so that's why we're combining different sensor modalities in order to overcome that when one sensor fails, that the other can still catch up. But it's a huge research project we do now to improve productivity. And I think we need to avoid that there is a difference between cobots and industrial robots. There should be no border.
Okay, I think that's the end of this session.
Yeah.
Thank you very much again, Shirley. Give it up one more round of applause.
Thank you. Maybe I have two short announcements, but we can close the online session already.
Okay. Yeah. Well, then we'll hear Shirley, and then we'll
we
up to
will
a coffee
be
break.
back in half an hour. Okay. So for the people who are here, at the end of the event. Hello, everyone. Good afternoon. I would like to introduce our next speaker, Shara Chandra Akaladevi. I hope I pronounced it correctly. He is a scientist at Prof, which is a research institute in Austria, and he focuses on robotics and automation systems. He has a keen interest in the integration of robots into human environments, and also his work in activity recognition and novel robot interfaces highlights his innovative approach to programming robots. I've already seen some work of his. I'm very curious to this presentation. Sharat, welcome, and please take the floor.
Thank you, Shirley. Robots have a huge potential in driving sustainability. They can be very effective in different sectors, from adhering to climate changes or answering the climate change problems to waste reduction and so on and so forth. However, the role or the precise role of robotics in sustainability, how can you quantify the precise role of robotics? How can you really say, okay, this is the exact impact of robotics in sustainability is missing? The data, the tools to assess this impact is lacking, and is also the cross-disciplinary research between different fields and robotics to address these challenges is also lacking. Good afternoon, everyone. I'm Shara Chandra Akaladevi from Prof, and I'm going to talk about sustainable robotics in production environments, and I'm going to give you one example of battery recycling and how robotics are playing a part in addressing these the challenges in battery recycling exactly, and then show you some progress in the projects that we are making. So that's going to be my agenda for today. Before I go on forward, I would like to interact with you a bit more. As Shirley mentioned, I'm doing interactive interfaces. So I would kindly encourage all of you just to open your mobile phones or laptops. Just go to menti.com, and then you can scan this code. And then I will put up a short questionnaire very, very quickly onto the screen in a moment. So I just give you a few more seconds to scan this code. If everybody is ready, then. Okay. Just a second. I already see some answers. So there you go. So what aspects of robotics in sustainable production are you most excited about to explore further? So from your point of view, in sustainable production, what do robotics have to do? So what can they bring in? There is flexibility, remanufacturing. We see social sustainability. Recycling has a bigger interest. Production efficiency, as we have seen. So I think that's transportation or transparency maybe. Okay, improved speed, safety, good. So as we see, there is quite some interesting aspects which we can further explore by applying robotics towards production environments, and especially dealing with sustainability aspects. So that's the whole point of it. So we have seen in the previous talks how robotics play a role, and how human-robot collaboration in specific applications can bring forth new avenues of applications. So I'll go back to my slides. Just give me a second. Good. So thank you for your participation. It was very nice. So coming back, so now I have your complete attention. So I will do some advertisement now. Yeah, I'm from Prof. We are a non-university research institute. We are established in 1995. So if you, we are from, Austria is a small place, but if you know Vienna and Salzburg, I will say we always are at the center. So if you are in the area, just give me a call. What we do from a research point of view is we have two research fields. One is industrial assistive systems, where we deal with deploying robotic solutions or assistive units towards production environments. And the other one is additive micro and nano production, so towards 3D printing, additive manufacturing, and so on and so forth. So I will not go into details. But yeah, we are interested in doing research projects or EU-funded projects. So if you are interested in pursuing some proposals together, I'm always open. And we are also doing bilateral projects with industries and also do some kind of consulting as well. Good, that's enough advertisement. So I'll come back to my agenda again. So as I promised, I will show you an example on battery remanufacturing. Why battery remanufacturing exactly? So as you know, the electric vehicles, they have been in the market since quite a few years. And if you look at the batteries in the electric vehicles, after a certain amount of time, if they lose the efficiency, which is less than 85%, then they are not worth, taking them into consideration anymore. So they have to, go for new batteries. And this creates an issue where you have lots of used batteries and you don't know what to do with them. So the general idea is you have, in the first life, as you see on the screen, you use them in vehicles. Once they are, used and they have the efficiency reduced, then you take them for second life. Meaning you take the batteries, check it if the battery is working properly or not. If some components are not working, you replace them, and then you use them for domestic purposes or second life. And then finally, even if after second life, then you go for recycling. You have to keep in mind that batteries themselves, when you take them into consideration, why do you need to recycle them? Why can you not just keep on creating new and new? You have a lot of raw materials in the battery. So there is a lot of mining, which is very, very critical. Right now, maybe it is not an issue, but in the coming years, it will be a very, very damaging impact towards the society. And that's the reason that is one of the critical aspects of it, yeah. And also, when you take the, as you can see in the market, you can see right now we had about $4 billion into 2024, and it's expected that in 2032 we will be at 42 billion. So it's going to be a huge, huge market that you are going to see this explosion of electric vehicles. But there are quite a few challenges. So this is the motivation. So you have used batteries, but there are also challenges. Like if you want to recycle or remanufacture these batteries, you have to consider that you have like 20 or 40 or 80 different manufacturers who have these new electric cars coming day by day, and they don't have the same structure. They are quite varied in the products. And the battery production, or if you want to dismantle a battery, it's a very manual process right now. It's a very dirty job, and it is also very safety critical job. Because the battery, when you take the whole component, as you can see, it's a huge thing, yeah. When you open it, there are also very dangerous substances inside, and then you can also be dangerous, fatal for the user if you are not handling the electronics inside properly. Even though they are not connected to any electronics, the electronics inside are dangerous enough that if you mishandle them, it can be very, very fatal. And you have, of course, a shortage of trained personnel how to dismantle these batteries. And the information on the product is also missing. So as I said, you have batteries coming from different manufacturers, and there is no clear data of how the battery was manufactured, what are the components located inside. So there is this data missing as well. So there is also this challenge that you have to take into consideration. So how battery remanufacturing works. So that's the cycle of the complete disassembly, as you can see. On the top left, you see the cover disassembly, yeah? And then you have to open a certain set of screws, and there is this heat shield inside. Then you have to remove the heat shield, and then you have the wiring, and then you have to do the unwiring. And after you do the unwiring, you have to remove each and every component. And each component then has to be tested to see how, if it can be reused or not. And this is, again, a manual process. And then once you remove the module, and then you have to then again reassemble it to, for the secondary application. So you have to consider the complete chain, and you have to consider the challenges and the criticalities in the process itself throughout the whole cycle of it. And those are the aspects you have to keep in mind. So what is the approach? Yeah, you have to identify the damaged modules. Yeah, you have to disassemble the plaque. You have to reassemble them, and then you take it for second life. But the goal is you want to do some sort of assistive system. So we say we have lots and lots of batteries, so we want to recycle them or remanufacture them. So where does robotics come into play? Yeah, what's the role of robotics then in this process? We have seen in the previous talks that you have the cognitive flexibility from the user. So the user is able to think or function or to make decisions very, very quickly. The robot is a very robust unit which can physically alleviate the task from the user. So the goal is always to combine the physical capability of the robot with the cognitive flexibility of the users. Yeah, that's the intention of human-robot collaboration. But the same applies to the battery recycling as well. Yeah, so we have seen there are different processes. However, not every process can be automatized. Yeah, you cannot apply a robotic system for a particular for each and every problem in the whole disassembly scenario. You have to figure out where a robotic application makes sense, where can a robot assist a user, where it makes no sense in doing that. So how we look at this problem is to divide it into two issues. One is where a physical assistive system makes sense, that where a robotic unit can assist a user, and where the user themselves would need some kind of assistant. It does not have to be a physical assistance. It is from a cognitive point of view, in a sense of a guidance point of view. The reason for this is you have in your factory not so many trained workers. So if there are new workers coming in and then you want to train them quickly, it's always a very intensive process. It takes a lot of time, it takes a lot of cost, yeah. And then the idea is to use the system also to guide the users. So on one hand, you have physical assistive units which are assisting the users in physically doing the task. On the other hand, you have the system itself guiding the user during the process by providing some hints on a screen or projecting some information onto the part itself, so that the user is capable of understanding what is expected next and thereby alleviating the process itself. And then we also have the issue of information. We have, as I've mentioned earlier, there is no set process or a standardized aspect of a product. So there are different kind of battery systems. The information through which, about which how the batteries were manufactured is also not very standardized. So there is also this missing link. However, thanks to the initiatives coming on, and there is also this battery passport which is required now until 2027. I think so. There is this initiative and also requirement. So this is being now addressed. So hopefully in the coming years, this aspect of battery recycling becomes easier as a result. Yeah, so the requirements to such assistive systems, yeah. So as I said, so we have such kind of physical assistive systems and also cognitive assistive systems. So, but what are the requirements? So to digitally to detect what's going on in the scenario. So for example, you have such kind of a use case where you have a part and then you want to inform the user that the part is dangerous to touch. So there is simply a projection interface on top, which is projected onto the part that is advising the user that it is not safe to touch right now because the battery is discharging. That's just a simple example. However, the system itself should be equipped with enough sensor systems and technologies to observe the situation, understand the situation, plan according to the situation, and then use the understanding towards guidance. And this is what happens in the guidance system. And in the robotic process, you want to also have the physical aspect then. So what kind of robotic processes do you want to include? Is it fastening or loosening of screws, separation of welding joints? However, from the physical process point of view, it is also very critical that you don't destroy the part which you're trying to disassemble. That's also very, very, very important. So you have to develop robotic processes to assist, but then you have to carefully disassemble it. So because for battery disassembly, you need to also cut some parts because they're glued together. And cutting these parts is very, very difficult, yeah? And if you cut too much, then you're going too deep, and then there is this explosion, yeah? If you're cutting too less, then you cannot separate it. And these battery packs are also very, very heavy, yeah? And we have seen use cases where, the robots were helping the users in carrying the parts. So that's very nice, yeah? But with batteries, also you can do the same thing, but imagine the safety aspect of it, not from the weight of the battery, but what happens if the battery will explode during the transport. It is very, very likely that the battery is such a volatile system that you have to consider that during the, this collaborative process, it might also explode. So those are very critical aspects we need to have in mind. So enough of those requirements and how the robotic systems and the cognitive assistance systems can help us in doing this process. I just want to show you one example where such kind of a cognitive assistance system and a physical assistance system can be in practice. This is a different use case. It is not on battery remanufacturing or recycling, but this should give you the idea of how the system looks like, yeah? This is from a different project. So you have different system components. So you have a projection system, yeah. You have a robot, of course, and you have a task of screwing operation, yeah. That's a very simple process, let's call it. So here we have integrated a physical assistive unit and a cognitive assistive unit. The cognitive assistive unit will guide the user to figure out, okay, what are the next steps? Where is the interesting part? Where do you need to do the screwing operation? And and what to do as a next step. So this is just to quickly guide the user during the whole process. And once the user is done with with their part, then the robot can take over by observing the whole environment. It knows that the user has done their part, and then the part has been moved to a new location, and now it can take over to do the actual process. So this is how it could look in practice. As I've shown, this is just as an example from a different project, but that's the idea of combining the physical assistive unit and the cognitive assistive unit together to help in a manufacturing scenario or a production scenario. Good. What are the existing challenges that we have? So as I mentioned, so the life cycle analysis is a very critical aspect we have to consider in terms of battery remanufacturing. I mean, in general, in the recycling and the sustainability aspects, life cycle analysis itself is a very hard problem. There are still quite some, there is still lack, and there is also not, it is useful, but there is not much push from different venues. Yeah. Then there is also this design for remanufacturing. What do we mean by design for remanufacturing? So maybe we can discuss that during the group discussion as well. But if you only produce, and then at the later point think about dismantling it, it will not work. You have to already think about dismantling before you start producing. So you have to design your products so that you are going to remanufacture it in the future. So that is what we mean by design for remanufacturing. And then you have this digital product passport. As I said, the data is missing, so we need standardizations. There are some initiatives, but still digital product passport on its own, it's still missing. There are some initiatives, as I said, like a battery passport, but for remanufacturing, I think digital product passports are going to be very vital. Safety aspects, as I've mentioned before, and also the low volume, high mix aspects. No matter what, we have to always think that, we have the human workers in the industries. The goal is not to replace human workers with automotive systems. The goal is always to provide assistive units so that we can use human skill more and more, keep human workforce in the working area, but make their working environment much easier than what it is. So that would be more or less what I would like to say. On an initiative or not from a technical point of view, but from an initiative point of view, I'm also leading at a EU robotics level the topic group on sustainability. So what we do at the topic group sustainability is we talk about the duality of robotics and sustainability. So one is, how can robotics help sustainability? On the other side, we also talk about how do you manufacture robots themselves sustainably. So you should also take the other side of the coin, that you don't use something which is going to so we are using robotics for such sustainability now, but are they going to have negative impact at one point? So think about what will happen if you have landfills of used robots. How to remanufacture these robots themselves, yeah? So that is also one of the aspects we are looking in the topic group. We are also actively collaborating with other initiatives, for example, with FARI, with BrIAS, of course, so with Carl, who is sitting here, and yeah, with Michelle, and also with Shirley. We have done quite a few workshops at EU Robotics, and yeah. So that's much it, but I have some more advertisement to do, just to show you some exciting EU projects. So there are ongoing EU projects at which we are involved in human-robot collaborative assembly. I thought it would be interesting to just share them here in this forum. One is Felice, which is dealing with amplifying fluency and ergonomics in human-robot collaborative assembly. So we have seen the project before from the colleague, how to have ergonomically suitable, collaboration. So this is one project where we have, which we have been doing, and then this is going to end this year. So just have a look at the project to learn more. And then there is a new project on multi-robot and multi-human collaborative tasks. So what we have in this project are 3 use cases. One is in construction, one is in automotive, and the other one is in farming, in agriculture, where we want to see in agriculture, for example, to develop a robotic system to pick up strawberries. So how, but transportation of strawberries, not picking of strawberries, but transportation of strawberries, for example, yeah. And then finally, we have a project called AI Prism, which is focusing on human-centered robotic interaction. And we have 5 different use cases in there, including furniture, semiconductors, food and beverages, consumer electronics, and also discrete manufacturing. So this is a project which deals mainly from a human point of view, how to develop AI technologies and human-centered robotic interactions. And I think this is also an interesting project for you to have a look at. So yeah, one final word, that's my team, who I'm working with in the robotics and automation system, which I belong to, and also visual computing team, where you have seen the cool projection systems and the object tracking systems that my colleagues develop. And that's all. Thank you.
Shada, thank you for your very interesting presentation. There's now time for questions.
Thank you. Lots of advertisement, but very useful. Thanks for letting us know about your work. I have a suggestion for a use case, perhaps for the battery manufacturing that you showed. There was a call. I couldn't find the link, but I can send it to you later. But there's a lot of attention on vocational training for technical people in Europe now. And there's a need for it, especially for developing new technologies and also training younger people. So some of the examples you gave could also be used for educational purposes, maybe combining sustainability and education together. So since you have already these prototypes that you've tested for sustainability goals, I think you can easily adapt them to educational purposes as well. Because this will be very useful to test different age groups. So we are usually thinking one type of people who would use these systems when we think about users. But you can get feedback from them, but at the same time contribute to their education as well. I tried to find the link, but I couldn't find it now, but we can talk about it later.
Yeah, definitely. Thank you very much. So we, just to add on that, so we are also effectively collaborating with other industrial partners who want to develop also for vocational training, but for their production environments. So what we do there is we not only combine the projected interfaces, as you have seen that, projecting information onto the parts, but also different types of augmented reality interfaces to help them understand how the task is going to be, what they are going to do, and they can already test before in the augmented reality environment before they go live into the field. So yeah, please do share the link. We can also meet during coffee. So thank you very much for that.
Is there another question? I have one, and maybe you can already connect your laptop while I take my notes, because I forgot my question again. Yeah, so one of the things you were describing is using battery disassembly as a use case. And considering that you described that it's dangerous, I'm wondering, why would we not let robots do the whole disassembly part and leave the safer jobs for people?
Yeah,
I just want to,
Yeah, because it's simply not possible for the robot to do all the disassembly. Because if you, as I've shown you an example, unscrewing the balls is easy, no problem. We have 20 screws, you can unscrew them. After removing them, there is the heat sheet, yeah? Then you have to cut the heat sheet. That's also no problem to some extent, but after you remove them, there are a lot of wire harnesses. Yeah.
Okay.
So you have to. You cannot. I mean, there are robotic systems which are dealing with this. Removing the wire harnesses, but it is much easier right now for the users to plug them out. But then again, to a certain extent, I don't think right now we are in a position to completely automate a robotic system to work with a battery pack. That's the reason we propose to combine some aspect of it with the physical assistive unit and some aspect where you can just guide the user. The guidance is not only to tell them what is the next step, but it is also to monitor that they're not doing something dangerous. Yeah, you don't want them to touch the robot when it is, or the battery cell when it is, going to discharge. So this is also, from a safety point of view, very important.
I see. Thank you.
I think there is one more question.
Can I just ask a follow-up question? Because I was wondering how the project was funded, because is there like some, because I saw it was from funding from Austria, is there like a battery recycling company that already exists, or?
Yes, I mean, there are, so for example, in this project I showed you, there is a MIBA battery systems, which was interested in battery recycling. So that is the project we are doing with them. So this, it's on the battery life project, which is funded by local funding agency from, and also there is a project called Demo Data Pro, which is dealing with the data aspects of it. So, but there are industries in Austria which are dealing with battery recycling.
Yeah, thanks. This one is about motivation, I think, of your company. In my literature research, I most of the times get to a point where a lot of people say the motivation is missing. There's a lot of tools that you could use actually in production or in development to try to be more sustainable, to incorporate the different dimensions, but most people don't really use it. It's not practical. I guess mostly it's the motivation or the money that's missing, whatever. So seeing someone who comes from a company that actually does it, or you are being like in this field and working on those topics, could you say like what is the motivation? I don't. Maybe you know. Maybe you can just have a feeling about it from Pro Factor, that they have you looking into those things so deeply.
So there are two different aspects. So I talked about battery recycling, which is interesting because the field itself is growing. And then I've already shown you how the market trend is. So from an economic point of view, it makes sense to develop technologies to facilitate this process. So we are going to have electronic vehicles which will keep coming now, and then we need to figure out a way to dismantle these batteries and then have them for second life or recycling. So that's one aspect of it. Sustainability on its own is a different aspect. I mean, it's a related aspect, but it's something a bit more, which does not only relate to battery recycling. Sustainability on its own, as I said, we have multiple, so there is a plethora of various fields which can kind of combine together to take this forward. So for us, sustainability is important from a production point of view. And we want to develop solutions which not only consider the economic aspect of it, but also take the social and the environmental aspects of it. But how we are considering as Profactor is not saying, okay, we are doing betterment for environment, so we are the best. So that is not the motivation here. We have economic aspects in the forefront, but we also consider the applications towards environment, and we also take the social aspects of it. How do you develop your technologies so that you cater to the human needs? So you put the human in the center. So we call it human-centered technologies, yeah. So that is also our key research focus, that we take the human factors into consideration and then develop technologies. So that would be our motivation, and then how it relates to sustainability. Thank you for the question.
Hello. I would like to thank Sharat for presenting his work, and then I will introduce the next speaker. Maybe I'll stand here. So welcome, Professor Aijung. We've already seen a presentation of you yesterday, most of us. So I will keep the introduction brief. She is a professor at McGill University in Canada. And she will, do it like this. And she focuses on AI ethics, robo-ethics, human-robot interaction, collaborative robots. She does a lot of experiments, and I'm very excited to hear this talk. Thank you for coming.
Great. Hello, everyone. I believe I'm the last presentation of the day before we open up for brainstorming. So today, you might have noticed in my title of the presentation, there's no collaborative robots per se, and I say service robots here. I will explain it to you in a second. What I thought I would do, instead of telling you my journey in more of the human-robot collaboration or collaborative assembly, where I did a little bit of my PhD work in, I thought I would share with you a bit of a story of a recent collaborative work I've done with experts outside of engineering, hooray, and then maybe inspire some thought-provoking questions for the brainstorming session, and also engage you in thinking a little bit more broadly about sustainability and collaborative robotics, in part because I hadn't really thought too much about it. All right, so about me, I am a trained roboticist. I have a little bit of a background in robot ethics, AI ethics. My group at McGill is highly interdisciplinary, but much more rooted in the technology domain than in other particular domains. But we try to be very, very interdisciplinary in our approach. So in part, we do human-robot interaction research, but also responsible AI type work. This is my wonderful group. We've got about 10 graduate students and many more undergraduate students to date, and we're expanding as we go, which I'm very happy about. But today, what I would like to do is actually tell you a story of 2 different papers that we recently published at HRI this year that involves these individuals. Chris is a research associate equivalent to a postdoc at the lab. He's going to be a new professor in Concordia University in Montreal, for those of you who may be looking to join him. Rahat, a PhD candidate, and Tanaka, a master's student. These are some of my lab students. And between the 4 of us, including me, we were actually really inspired about this particular idea. At McGill, we have this lab called the Retail Innovation Lab, which we are part of. And it's, as the title might suggest, it's a retail lab. It's a living lab where Couche-Tard, which is kind of a convenience store brand in Quebec, they've created a store within the McGill campus that's actually a working store where people actually go in, grab their coffees or snacks and whatnot, and that's actually also being used to do some research in the retail space. And I thought, well, they've invited me to be part of this group, so of course what I'm going to do is bring some robots in. And I wasn't really sure what to do with it. I just wanted to kind of come up with a cool use case where robots can be in this space and be really great, and then maybe I'll publish something about it. And so I brought these wonderful students into this kind of thinking hat and say, okay, what can we do when we bring some of our existing robots into this space? And one of the things that we came across is, oh, maybe robots can provide a little bit of a service function within the convenience store, so that if you have any mobility challenges, maybe you have a hard time bending down because you've just had a back problem. Well, maybe it can actually grab something on the lower shelf for you. Or if you have a hard time reaching because you're a kid, maybe it can grab something that is higher up for you, and so forth. By happenstance, we came across Joe, who is now our collaborator and a professor at the University of Montreal. He happens to be an expert in training clinicians who work with people with visual impairments, the blind, or people with significant enough of visual impairment that they have a limited capacity in that sense. Now, we connected with Joe by happenstance because we thought, oh, maybe these robotic systems can also help the blind or the visually impaired find different items, or help them out in their shopping experiences. And we thought, okay, maybe we should do a focus group, maybe we should engage and find out, who do we know who has visual impairments, and ask them what they would like to do. Turns out Joe has already done that work. So we have connected with him, and we told him about our brilliant idea of bringing the robot. What can the robot do to kind of help this community? And then he told me, he showed me this particular results. This is from his group, actually. He had done a focus group involving 20 different people in the blind and the visually impaired community. And he essentially asked the focus group, in your daily activities, such as going to a store, going to the doctor's appointment, hopping on a bus, going to get coffee by yourself, these kind of daily activities, what are some of the barriers or facilitators? This is what the focus group results actually look like. I have handily highlighted two different things that are really important here. In terms of barriers, these individuals said, okay, inaccessible signages that I cannot read because it's too small or it's inaccessible. That's very, very unhelpful for me. Difficulty in walking because the ground and so forth. Or problem finding the location because maybe it's inside a gigantic mall where GPS doesn't work very well and so forth. But then, unsuccessful interactions with humans is also a barrier, because you may be going to the doctor's office, looking for that office, and then ask for help from a person, and then this person says, oh, over there, and walks away. That makes you feel like, I don't want to ask anymore. And then now, you're going back home. Same thing for facilitators. It turns out there are many different things that could be facilitating their activity, but the most amount of facilitation actually comes from helpful interactions with people. And so the context was that we envisioned this retail space where it could be a frictionless space. For those of you who know about Amazon Go store, we are essentially trying to remove as many humans out of this retail experience as possible. So you walk in, frictionless, you grab whatever you like, and you walk out. You don't have to interact with a human at all. And now, reflecting on what I've just told you about the results of helpful interactions with people, if we were to create as many of these smart spaces as possible that is absent of any humans, then this particular population of the blind and the visually impaired population will actually have a worse time in their shopping experience because there's no one to ask for help. So we thought, okay, maybe we can learn from this. And it also turns out from this experience, and I promise I'll come back to collaborator robots. From this experience and our communication with Joe, we found that there are many different misconceptions that we have about different people that we don't usually interact with or know too much about. I found out, for example, that there's 2.2 million people with visual impairments in the world today. That's quite a lot. I also found out that just because we talk about the blind, that doesn't mean it's complete blindness. There's only a small minority of this community who actually are born blind or are completely blind. Most of the people with visual impairments kind of have vision like this. partial blindness, as in they can get around, they can see things, but it may be very, very blurry. It may be actually blocked in a particular way. So their particular visual needs is actually different from one condition to the next. I also found out that for this particular population, one of the facilitators that they talked about as enabling their retail or daily activities did not involve a lot of technologies. Because we expected that, well, there are many different AI tools around to help you to identify different things, or Google Maps and so forth. Turns out the things that they found really, really useful for them are things that we use daily as just regular Joes, which is iPhone or any kind of smartphones. Any kind of map apps that we all already use are the kind of apps that they like to use as well. Part of the reason for that is because they don't want to feel special. They don't want to feel like they're using assistive tech, because that in itself is a very stigmatizing experience for them. And so through this experience, we wrote up a little bit of a paper talking about how, well, maybe use of robots in a service sector, we need to think about things like stigma, think about things like how do we design these robotic systems so that it's actually friendly to these particular populations. That includes things like, if you have a fancy minimalistic robot that has a tablet feature where you can actually press some buttons to get what you want, actually that's very, very inaccessible for this particular population, because most of the glossy tablet features are too much of a glare for them to actually interface with. And any of the buttons you might have on the tablet, it doesn't have the haptic features that allow you to select, okay, that is number 1, that is number 2, right? So that in itself, as a design trend, is eliminating a lot of the accessibility features for them. Okay, so one of the design principles that we found out about, and I'm not an expert, but I'm a fan, becoming a fan of this notion of universal design, and I would like to pose this to more of a collaborative robotics domain, is really this notion of universal design versus inclusive design. Universal design is really the idea that you can create a singular design that happens to serve as many people as possible. A traditional example for that would be a ramp for a building, for the wheelchair accessibility. You design a ramp into a building that not only allows wheelchair to access the building entry, but it happens to be very helpful for the UPS drivers or whoever is doing the delivery, or even people who are bringing their bikes into their offices. It ends up serving multiple functions. Same thing for even toilets. Now it's popular to have gender-neutral toilets. I'm a very big fan of that. If you have big enough of a space for wheelchair accessibility there as well, then you have the singular toilet situation where everybody can benefit and make use of. The question is this: can we design robots with this universal design? What would a universal design of a service robot look like in such a way that there is this one service robot in a retail sector somewhere that people who are not able to see well can use, people who may be deaf can use, children can use, the elderly can use, people with mobility challenges can use. Can we think of a design solution like that? On the other hand, there is a notion of inclusive design. Inclusive design is really the notion that, well, okay, we want to accommodate the special needs of different populations with special designed features, such as, okay, if you would like a service in English, press 1. All right, we will accommodate English in this particular service. For French, press 2, and so on and so forth. Equivalent in the service robotic sector would be that, okay, if you have visual impairments, please select this robot to interact with. If you have auditory or hearing difficulties, please select this other robot. And you can already probably tell that if we were to have many different robots just to service inclusive design, to be able to accommodate different people with different needs, well, we might actually end up with multiple robots that don't actually get used very much. Or we may be trying to incorporate as many of these kind of features in one robot in such a way that it's actually way too expensive to deploy at the end of the day. So I think that's a big question for us, well, in part from the retail and service sector. But I think that brings us to the notions about collaborative robotics. Maybe it's not going to look, maybe it will. Okay. This is one of the ways in which we were looking at human-robot collaborative assembly. In this particular section, I'm not going to go into the details of the study itself, but one of my PhD students is actually looking at how the movements of a person in a pretend collaborative assembly scenario actually gets modified or influenced by a robot and its changes in the motion. And in creating this kind of experience, our stereotyped assumption is, well, it's going to be an able-bodied working adult population in a manufacturing kind of a context, working with a panda robot or a robotic manipulator like this. But maybe we need to rethink that too. Maybe when we think about collaborative robotics, we're thinking about this kind of industrial production kind of a setting, in part because that's where we have seen traditional industrial robots that didn't collaborate with us in the first place. In reality, this is a photo, a scene from a popular movie, Parasite. In this scene, there's this family who is just folding pizza boxes. They get paid to do this job, manual labor, and they get to do this at home, and somebody picks up and pays for them for their labor. This particular pizza folding labor is symbolic of the kinds of labors that we don't talk about when we talk about collaborative human-robot interaction. We don't think about bringing these robots to people's homes for them to amplify their own production value. Especially if I go back to the historical setting of the Korean labor back in the 50s and 60s, there were many kind of cases where the grandmothers or the mothers would have side jobs. They would be shipped these stuffed animals, and their job would be to actually sew eyes onto the stuffed animals. And at the same time, they can take care of the children in the home. They couldn't go to a factory and then get a full-time job there because who's going to take care of the kids? That is the reality in many different parts of the world today as well. When we talk about collaborative robotics, I think we don't think about them. We think about the companies, in part because that's where all the money is. That's where the investment for robotics is. But maybe that needs to be challenged as well when we start to talk about many different sustainable development goals that we could be unlocking together, especially when it comes to reducing poverty, maybe better ways of jobs. Even if I were to have a pizza folding job at home, maybe if I am able to access these robotic systems that can make things easier for me and I can work at home, maybe that'll mean something completely different in terms of what does production mean across the world. And I will leave it there. Thank you.
Thank you for a very interesting presentation. Is there a first question?
Thank you. This was an interesting perspective. So I was wondering, and this is a question perhaps also for the next session, there are probably efforts, but maybe you can remind me of, are there like second-hand robotics? This is also, I think, useful for sustainable purposes. Like not everybody can get a brand new telephone, etc. Same for robots. They are very expensive. Like even for research purposes at the university, when we want to buy them, they are super expensive. So I would be interested in just getting a second-hand one, for example. Is there a market for this, or have you? I think this also aligns with your last example about involving people who are outside manufacturing as well.
Yeah, thank you for that question. I don't know of a second-hand market for industrial robots or collaborative robotics per se, but I do know very, very informally that many of the interactive robots that has been designed and has been put into place, sometimes they quote-unquote retire. They become essentially decorations, in part because many of the companies have gone bankrupt. They no longer provide parts that allow you to repair and continue to use them. And some of these robots can include things like multi-million-dollar platforms that used to exist and no longer serviceable. I agree with you. It's super expensive. It's a huge, huge cost in many sense of that word. Now, I would love to see more work in actually developing robots where the parts can actually be used and repurposed into other forms of, maybe modular forms of robotics. Maybe I was talking to somebody about soft robotics as well. Maybe much more recyclable or even compostable materials, so that even if the technology develops and necessarily has to create lighter, faster, but safer kind of an interaction, maybe we could actually have cheaper, in terms of climate costs, manufacturing of the robots.
Okay. I see another question.
It's not a question, but a comment on the previous one. So on the second-hand robots, so what we discovered is there was a robot for milking cows. So there is a market of milking cows using robots, and there is a company called Lely, L-E-L-Y, and what they do is they have these milking robots, and they remanufacture or refurbish these milking robots for farmers to sell them as a second-hand robot. So there is one success story that they built their business model on top of these refurbished robots. So maybe you can look at Lely robots, so just for an example. And regarding this universal design for robots, I like this idea very much. But from a practical point of view, from an economic point of view, how realistic do you think this is going to be? And yeah, any opinion on that?
I think it's extremely hard. And I think because it's extremely hard, it's something that at least the academics need to really invest some time in part because I think there's a lot to lose if we don't tackle this kind of challenging problems, because we will end up designing very special function this versus that, where we have duplications of many different robotic parts and systems that we just simply cannot make use of in the most diverse way possible. So from overall efficiency perspective, I think it's something we need to solve. As far as technical advancements of today to make this work, I think there are real physical limitations, but I think part of it is also that we haven't really had a lot of conversations about it. We haven't really fully brainstormed what a universal feature of a robot could look like. What does it mean for us to actually build this kind of, at least a shell of a robot that can be multi-function, multi-purpose, accessible in a way?
I see another question.
Yeah, maybe also not really a question, but a comment on your last answer on the question from Sharat. You said, or you put up the question, can we design a universal robot or that is fit for everybody? And I think it's really important to point out that probably this we is not academia, but it needs to be done in a fashion as we heard from Shirley before in the workshop. Yeah. And in our project, we also had some interviews. I mentioned already that we were a bit late with the participation, but it was really eye-opening how if you include people from different point of views, we had someone with a visual impairment, we had someone with a mobility impairment, if you say it like that. And they were bringing questions and statements to the table that we never thought of. And I think it's really important, and I like the idea of this universal design, and I think also it's really hard Even now, I think to make a robot that has multiple functions is really hard. Most robots seem to have like one specific function. But yeah, it's really important to bring in everybody that needs to use it. And maybe there's robots that will not be used by people in a certain, affected by a certain way, but everybody who will be affected should be brought into the design. And I think then it might be possible to actually do this universal or reach this universal design. Thanks.
Thank you. Yeah, just to clarify, I did not invent universal design. It's a concept from the 90s that other people have done great things about it. But yeah, I'm becoming a fan. I'm happy to create more fans.
I see. Another question.
I was wondering about your accessibility experiments. So when we're designing robots or when we're thinking of it, we have this idealistic robot that is capable of doing things, perhaps better than humans at certain times, but humans vary a lot. So, and we also age, so our abilities change over time as well. I was wondering if there is literature in your field looking at the accessibility, like we always think of robots that are perfectly capable of seeing, hearing, but are there also robots which have less of these abilities, like humans? Do we consider, for example, collaborating with them? Not only maybe with visual or hearing, but also, for example, lack of an arm, like an old Barbie. Sometimes you crush one of the arms, but you still love it because it's your Barbie. Or with other toys, like toy robots, sometimes one part is missing, but you still play with it, like a wheel is missing. So I was wondering if there's any research on this.
Yeah, thank you. So the question is more about robots having different abilities rather than actually working with people with different abilities.
Right.
Yes and no. I would say all robots have different abilities, and the design challenge has been how the morphology by design of the robots actually give out a mismatch between what people expect the robot to be able to do and then what the robot has been designed to be able to do. A kind of stereotypical example would be if you design a robot that looks like it's got a head with ears and mouth and eyes, then people will expect it to be able to see you, attend to you, hear you, and be able to speak. We haven't actually, managed that until very, very recently in specific cases. So matching that kind of expectation to reality has been a bit of a challenge. So I think in HRI we see that a lot. That many users kind of have this impression that, well, if it's a fully autonomous thing instead of a Wizard of Oz where humans are making everything sound very smooth, that we're kind of disappointed that, there's a delay in the speech and it's not as intelligent as I expected to, and so forth. So I think we're kind of always in that side of the story. But to add to that, I think something that you're touching on is the sense of relationship that we might have with these kinds of robots. There are literatures about the attachment between humans and robots. Even the role that a Roomba would have or a vacuum cleaner would have with a particular family. I think it really depends on the family dynamics and so forth. So yeah, there are some literature around this.
I see no more questions, so I would like to thank Professor Ae-Jung-moon again for her talk. And then we'll have a group discussion. Is it already in the table? No, it has to be. Oh. So now the last part of the program, the opportunity to have a group discussion. I always, when I have a panel, I'm not in the panel, I'm always like, oh, but I also want to say things. So I thought, as a change, we try to have more of an interactive discussion. But first, I would like to ask you to scan this QR code and participate in the MOOC lab. I will also do it myself. If it works. Yes, I don't see the question yet.
Yeah, we just need to everybody scan first, and then I can.
Did you reset the question?
Yes.
Okay. I don't see it yet. So.
I know. I need to swap.
Oh, okay. Sorry.
If I swap the people, then.
Yes.
Now we have the question. How to answer.
I would suggest don't peek and fill it in first. I see the questions are still coming in. Let's see. Move this up. So this morning, for those who were not there yet, we also asked this question, and it was mainly an audience of people interested in healthcare. If I look at the results now, I see that good health and well-being is also still on top. I will scroll down a bit if I can to see the other results. I see climate action is also an important one. Oops. But quality education also stands out. I think it's also an application that you can be used in production. So the idea here now is I will have some questions, and then everyone who wants to respond or react to that can. Misha, would you maybe mind to walk around with the microphone? So maybe I would start with the concept of remanufacturing. Yes, they can. If people are fine with that, is it okay if we turn the camera so people can see who is speaking? Yeah? No? Yeah. So one of the things I was fascinated about is the concept of what Sharat talked about in his presentation on remanufacturing, on how can we design for this? How can we design things, or maybe robots or other things that they are actually already meant to be reused? And I think you also touched upon that. Anyone who already has some thoughts on this?
Yeah, I think it's also a vision on design that's already also existing for a long time in the design community. It's cradle to grave, so that you actually have this trajectory in your design already, that you know from the moment that you create it till actually it's put out of use, and that you already designed for it. And so there are also like methodologies already available for that. So we don't need to reinvent that. We just need to adapt it, I think, to both robotics and the use cases where we put robotics into use for that. But it's often overlooked, and I think you actually, in your research, you mentioned that, what the problem actually there is in the adoption. So it's not the lack of methodologies, it's the lack of practices with those methodologies, I think. So I think you can continue better on this point.
Maybe you can repeat the question. I was busy with the technique. I heard her answer.
I can summarize. So Sharat mentioned the concept of remanufacturing, about designing with, in keeping in mind that you can reuse it from other purposes. And then Anne continued to say that, well, actually, those methods already exist. We can use them from the domains. And then I wanted to ask Anne, actually, from which domains? I assume product design? Yeah.
That's where I come from, and as far as I know, it's true. There's many design methods that are really actually made for this, and you can apply a lot of different goals into the design that you can shape it into, as Sharat said, make it a design for X as one, or design for, or design 2X. And X could be anything. It could be remanufacturing, it could be sustainability, which is in this case a bit broad, but it could be recycling, reusability, etc., meaning that you, in the design process, put up that goal or that requirement a bit higher in the priority of your usual development phases or usual design procedure. And I think the problem there is, again, the motivation, and that usually you have the commercial effects or the financial aspects are very high up. So time and cost is the two most things that are mentioned and that are used and that somehow stand above everything else, it seems. When I was at a convention, the Automatica, and I was trying to kind of interview the different people from all the bigger companies, and ask them about how they value design for sustainability. It was really mostly that they said, yes, it's a good idea, we need to do it, but we're not doing it. Or we're trying to do it, but this and that. And I think it was one worker from a bigger Danish company who said, who was like, I can tell this, but you cannot name or put my name in the interview. That he was, I think he had a task to put a robot in place in a manufacturing, like a battery, I think, and it was from a company that had really bad press, I think, in Germany, and he was actually then asking himself, do I really want to do this? So he had some thoughts about it and went to his boss, and the boss was, or his chef, his boss was saying, no, it's not the high priority. We need to sell, and that's the more the high priority, that we need to make a business, and sustainability comes second, third, or whatever. So it's the I think reality that in design or in the industry, it really, we need a motivation or a regulation. I think those are always the two things. Either you have a push or a pull, and that's pretty much where we need to go. The methods are there. It's not a lack of methods, and it's not that we need to invent the new wheel anew. And whenever you asked the people, there's also a lot of studies about that when you ask designers, they always want a tool that works for everything, but that is not complex, and that is doing everything, but in a very easy fashion, and that's also not possible. So I guess you need to have different people in the production processes that are familiar with those terms. You cannot expect one designer that's coming from an engineering part or studies that's focusing more on the functionality to also know about social sustainability, environmental sustainability. I think you need to have more different people, which again will then be more costly for the company. So it's always a weird spot to be in, and not really easy to solve the issue or the problem, I think.
I'm
sorry, that was a bit long.
No, that's okay. It's a group discussion. That's why, I'm wondering, is I'm looking a bit at Kristóf because you're maybe also still involved in education. I don't know. Is there some attention being made to also, let's say, universal design or sustainability in the education? Is that something that's considered at the moment?
Well, I know that there are subjects that can be taken by any students in the university regarding sustainability, or even I had a subject about basically recycling plastics, but these are usually not mandatory or not really serious subjects, so to say. But it's just one university out of many in Hungary, and it's just Hungary out of many of the countries in the EU. So I am not sure, maybe someone else from some other countries can say something.
Yeah, again, me, I don't know if anybody else has a comment on that. Maybe you can go first, so it's not me again. But okay. We had in the University of Berlin, the Technical University, a group of colleagues that started a new course about sustainability in the design process or the development process. And there we tried to touch upon, they made up the course and I helped with a bit of my project experiences, but there we tried to come up with all the different parts or the different dimensions of sustainability and try to teach them what kind of tools they could use and just to create a certain awareness. And it was more a practical approach. They had a task to reinvent or invent a new product and then see or use methods to actually improve the sustainability. And I know that they wrote a paper about it. I know that we had a colleague from another university, from Bochum, I think, who wrote her PhD about it. So it seems to be a very new thing and not very established. And that a lot of research that she has done in Bochum shows that it's really necessary and uncommon and therefore necessary to put these topics into the engineering world, because there's not really a lot of overlay from those disciplines. I think also one of the papers that Carl co-authored showed that sustainability, just the name or the definition, is not really common in the robotics world, and that we need a bit more of an overlay. And I think we can try to do that with the conference and with papers, but we should probably go into education as like the root of all of it, and hope for the next generation to be more aware in terms of that.
So I'm not in the academia, so I cannot talk about training and education, but and also since I'm in research, I'm kind of in the middle between the design process and the application. But actually I think that as researchers that are working on innovation, we are probably the one that have to, let's say, push for sustainability into technologies that can be applied into industry, because as we said before, there are some companies, mostly the small company, that cannot think. I mean, they can think about sustainability, but it's not their priority, because of course their priority is to make the company work. So it's kind of our, responsibility to try to take care of sustainability more than what they can do. And actually, my research institute, we realized at a certain point that all the groups, we don't just have robotics, but we have also have neuroscience, life science, many things actually. And each group, each department was somehow including sustainability in their work, but not in a well-organized way. So this year, from 2024, we decided to put, the people at the high level decide to put these, they call them flagship for the whole research institute, and one of them is about sustainability. And basically what we are doing is to try to organize in a more structured and better way, let's say, the way that all the various departments try to achieve sustainability inside their work. So hopefully by 2030, because it's a 6-year program, we will be able to, have improvement in this sense, and we will try, of course, to apply it also outside the research institute.
I just want to add one thing, because when I was doing my PhD at Singapore, my supervisor is also working with, we are not working with robotics, but we are working with flexible electronics, stretchable electronics. That is also in, I think, in next 5 or 10 years, there will be a lot of wastes coming from there. Not in terms of electronics, also from the health sector as well, because people are fabricating a lot of sensors and all. So they have like a very big project where they recycle the solar cells, the batteries, and from, I think, in 2017, it's already in Singapore. So the problem in small countries is like the size. They have a very small size in that. So they are thinking a lot in terms of bigger countries like India, for example, because they have a very limited space. So, and I also believe that recycling is going to be a next thing for modern kind of experiments or technology, because at the end of the day, we are growing bigger and bigger, but the space is going smaller and smaller, which I have seen in many, like in Singapore. There is people are going either going up or going down. They are not extending in horizontally. So that's the problem. So I think not in this, but the coming years, the recycling will be the top priority. That's my comment on that.
Thank you for your comment. Maybe I want to respond to both you and Marta. So for I think like having these goals from your organization and having them as a, I forgot how you called it, was it moonshot or like a vision? Flagship, that was it. Yeah, there are all these, you know, buzzwords. Yeah, I think that's probably one of the ways how to make people more aware of the SDGs, I think, and well, and related goals. And I think for myself, I think that a lot of people actually already were working on these different sustainability goals, whether it was, you know, economic or social or environmental sustainability. But now, because these goals are there and we're talking about them a lot, now everyone is having this, I think, a reflective exercise where they, okay, I do this, does it match those goals? Where does it match? And where is it that I'm sort of finding, trying to find a balance between what Anne was referring to in her presentation this morning? That's always a balancing act. We can help workers, for instance, to help lift them heavy things, help with things like we saw in Marta's presentation, and save their, let's say, their health. On the other hand, we also want people to enjoy their job, so we should design these new interactions with technologies such that there is still place for that, for people liking to do your job, because sometimes you hear people say, oh, well, I think working in a factory is very boring, but the people, for instance, I interviewed in the car factory, they were working there for many years. They each have their own system and they're proud of the work they're doing. They're contributing to, well, in this case, it was creating a car. And yeah, that's also an aspect that we should consider when using robots.
Yeah, just to add on top, so you said we have robotic applications and then we have sustainable development goals. We see, okay, we have this application, which kind of sustainable development goals does it cater to? Yeah. There is also this aspect of, okay, I have something, how do I kind of phrase it in a way that it kind of applies to SDGs? So the greenwashing aspect, if you want to call it like this, yeah. In any case, so what I... yeah, SDG washing, yeah. So that's kind of a, it's an issue in a sense, yeah. However, what we have to also keep in mind is that how do you to quantify that your application is sustainable? So what do you mean by when I say, okay, my application is sustainable? What does it imply? How do you say, okay, it is sustainable because of that and that reason? So what are those metrics that you kind of can quantify for these applications? There is application on one hand, and the technologies that use on the other hand. You use robotics, you use AI, you use some other technologies, but there is this quantification of it. this is not clear, at least from my understanding. If there is kind of a quantification of it, okay, when you can say, okay, these are the tools that we have through which you can say the application can be quantified, and this results then in a sustainability factor, if you want to call it like this, then that could be a baseline to say, okay, yes, my application is then sustainable, instead of going towards greenwashing or SDG washing or whatever. I think this is a bit more logical way to proceed. Just an opinion and a comment.
Yeah, I would like to respond to that, but maybe someone else wants to go first. Yeah, go ahead.
But you can also.
Okay. Well, I'm. You're asking for how to measure it, and I think I don't have an answer to that, but I do have some ideas about, the right to repair, for instance. So if you have an application, the first thing I came to mind for me was the Fairphone. So the idea that if you have something, you can just replace the part. Like it's for me, but for exoskeletons, for collaborative robots, we put an exoskeleton on a person, we accidentally break a thing off, we send an email to the manufacturer, and we get a piece back, and that worked. But I don't think that's always possible. Like sometimes if you break one part, then you just have to replace the whole thing. So I think that could be one aspect, one maybe part of that metric, but there's probably so much more that should be in there. I probably also people working on, like, how do you say that, ISO standards for that.
Yeah, maybe I can comment on that, or from what I learned during my research. You probably know the LCA, the life cycle analysis, where you try to, I never know if it's analysis or assessment, but either way, you follow, there's also a standard, an ISO standard, I think it's the 1404T or something like that. And there you have very clearly described what you have to do to analyze your product, your process, how much of a system you want to look at, just the robot itself or the infrastructure, the charging, the whole, transportation, etc. And then you can put all those processes with the help of some databases into a sort of calculation, and then you get really clear quantitative results out for what you then call the LCI, the life cycle impact assessment, where you look at different factors. And the usual way to do it is the recipe factors. They're called at 16 different categories where you have a really clear number. And so that is a pretty easy way to quantify your impact. The only problem for us was in our project so far to now you have the numbers, what to do with it afterwards, because there's no way of saying when you have this number it is sustainable or less sustainable. That's another thing. I think you can, if you build a robot, it's never going to be sustainable. You can make it more sustainable or less sustainable, but you can never make it sustainable, but because it will always take up batteries, it will always take up raw material. There will be so much that this robot has impacted already during the production process that it's really hard to think of it as sustainable, but you can make it more sustainable. And the problem we had is really like what is the standard, what would be like a threshold, and could there be a threshold, and how to measure it, because the usual way to do it is now you have like a mean that is compared with like all the people in the world, how much they usually add into those impact categories. And that's also somehow a bit weird, because you never know if my product that I'm producing or I'm looking at during the LCA, how many people will it affect, or for how many people is it? So can I really compare it to the mean? And is the mean a good or a bad thing? Maybe the mean even says, or could imply that we have a problem with certain categories, and not really saying that, okay, my product is not above but below the mean, so that means it's good. It's not really easy to say whether it's good or bad, and you can only really use LCA for comparing a product with another product. So if you want to put it into a design process, you really need to compare 2 or 3 different scenarios and try to choose the best one. And then from there going, you can maybe also try to by, I guess, regulations or something else you need to put in a threshold where you can say, okay, this is like the maximum we can use up. But there's always a problem with measuring that. And then also the 16 different categories have 16 different units. So whenever you try to compare one product to the other or one scenario to the other, it's really hard to how to trade off the different pros and cons. Let's say the one product is good in the CO2 emission, or like not that much impact, but the other one is good in the, I don't know, toxification of salt water, sweet water. Like, how do you trade off those two things? That's really hard, or one of the questions that I dealt with and I will probably deal with in the future.
Thank you, Michel. Is there another last comment to Michel's comment?
So I have a comment on this, and also I wanted to answer to your previous comment. So the nice thing about create this regarding the flagship is the fact that maybe it's important to do some kind of interdiscipline work towards sustainability. Because the idea there was that, okay, maybe the people that are working on robotics are trying to work towards sustainability robotics, the people that work in life science, they are doing it. But the best results will be obtained if you put people together also about different fields, because they probably can achieve better results if they collaborate together. Just to give you an example, we did a nice collaboration work with another group that is working in smart materials, and we basically create a device which has some purpose related to our application, but is made of biodegradable components, and it can be powered by solar panel through conductive ink. It was a very nice collaboration, and it gave us the idea of how much effective can be collaboration towards sustainability. And I wanted to connect this also to comment on what you said before, because I think that also in terms of the different SDGs, while I was looking at them during the whole day, during the presentation, I was thinking, okay, but how is it possible to achieve them all together? Because probably when you try to achieve one, then you have some drawbacks in another one, and I mean, it's not easy to improve them all together. Probably you need to find a compromise, and I think that this can be achieved by doing this interdisciplinary work. And in terms of matrix, probably it will not possible to achieve super good performance in all the objectives, but I guess that it really depends on the application. So in the end, it is a matter of comparison. I mean, I agree with you that the only thing that you can do is to compare what you have before with the new technology that you're proposing. For sure, you will not reach the best performance in all the objective, but at least you're improving what you have before. That's my comment.
Thank you, Marta. I think indeed, I think collaboration is doing a step forward, and I think we're with many of us also in the BrIAS program and also in the conference today that we are all working on a part of it, and it's baby steps. It's like step by step and to make impact. And on that note, I would like to thank you for this group discussion. I will give the word to Professor Emanuele Garone. Yes.
Thank you very much, Shirley, and thanks to the organizers of this very nice meeting. Actually, let me apologize with most of the speakers, as for various reasons I could be there or just for very small spots. But it was what I saw was very interesting. So the last thing I want to do is to just advertise a little bit the last of the 4 public forums of the Brussels Institute for Advanced Studies for this year. That it will be concerning the usage of robots in war and peace. Now, you know that the theme of this year is about the sustainable goals of the United Nations, and one can think, where is here the sustainability? And if you see one of the points that is one of the goals that we have in the sustainability, it's peace. And actually that's, if you think, it's one of the first steps to be able to obtain development and possibly sustainable development. The fact of not killing each other, it's actually really a fundamental prerequisite to do something good for ourselves and our planet. And our question when we started thinking about this year, more or less 1 year ago, was to reflect not only at the aspect that, like today, in what we have seen in the various in the various talks, represent positive aspects, but also which are threat to sustainability. And of course, war, as I just said, it's a huge threat. And this forum wants to investigate how robotics has changed and is changing the face of war. So also, what are the responsibilities as roboticists that we have, and which is the ongoing discussion about the usage of robotic at war. And this is, of course, a grim side of the story, but also as robotics can do something after wars. Now, remnants of wars, it's something that, I must say, especially in developed countries, we tend to forget. So there is a war, we make a mess somewhere, and in the last 40, 50 years, especially Western countries, made a mess somewhere, and then they went away and they left the mess. And by mess, I mean unexplosive ordnance, mines, underwater mines, all this very nice stuff that even after the war, they prevent a normal return to life. And if you study a little bit data, are scary. So they speak of millions of mines still from World War II present in our seas. They speak of millions and millions of mines present in the various areas where battles have been fought, a lot of unexploded artillery and so on. Now, we are in Belgium, and this is something that is really felt here. Consider that even nowadays, every year, a huge amount of unexploded ordnance from World War I is found in Belgium. And we have been to the unit of the Belgian army that it's devoted to deal with them, and they showed us that the line is not going down. It's years that it's always constant. Every year they keep finding new remnants of war, including toxic material and so on. So robotics is a threat when we speak about war, but is also an opportunity for a more fast return to life. Just another number that comes to my mind. There is a Swiss think tank that has computed with the current technology and the current resources how many years it would take to clear of mines Ukraine after 2 years of war. And the number they come out with was more than 700 years of work. So this just shows the really the sheer volume of the problem and the possibilities that our communities can do something for it. So in this forum, we will approach these two problems. So peace, by peace we mean what robotics can do for the return to peace concerning remnant of war. And this will be mostly the first day. And it will be, I would say, more technical. There are more roboticists, more people speaking about technology. And then we will have a second day that is instead on the green part, that is what's happening now in the world concerning war, and which are the current ethical, legal, and historical debate concerning it. So this is what we will do. We will also have a very last intervention concerning how science fiction predicted what's happening and what science fiction predicts for the future. And so I invite all of you to participate. I hope that can be of interest. I hope that this can spark debate. I thank again Shirley for giving us this this space to talk about it, and I hope to see many of you there. So thanks again. I give back the word to Shirley because I imagine she wants to say some conclusion on this event.
Thank you very much. I have another slide just to show the location of next time, because it's a new look. I mean, it's new as in most of the fellows haven't been here yet. At least I haven't been here yet. Then some closing remarks. So yeah, I would like to thank everyone. I hope I'll not forget everyone. I would like to thank the BrIAS Institute for giving us the opportunity to organize this special event. I would like to thank all the speakers that came, some from outside Belgium, or maybe most outside Belgium. I'm too tired to think about that. But thanks everyone. I would like to thank the directors for their support in this initiative. I would like to thank Anja. I think she's already very busy in supporting the reception that will follow afterwards. I would not have been able to do that, this forum together with her and my other fellow organizers. Carl, thank you for moderating. Bernardo, I'm getting tired. Tamas, Kristóf, thank you for help with the organization. And I would also really like to thank the junior fellows that helped, a lot without even asking or asking. They asked me what I needed, and just being invisible like helpers. It's really amazing to have worked with you. Then I would like to conclude. Thank you, everyone. There will be some drinks, there will be some snacks, and I hope to see you again to talk with you more at the reception.